Hey there, creative developers. In today's tutorial, we're diving into something truly next level, building a stunning portfolio website that not only looks modern, but feels alive. We'll be using React for a rock-solid foundation, Tailwind CSS to style everything effortlessly, and Spline to bring in a jaw-dropping 3D model that reacts to your users. But that's not all. To make your site truly stand out, we're animating entire sections with Framer Motion and GSAP, giving you silky smooth scroll animations and eye-catching transitions that will wow anyone who visits your portfolio. So if you're ready to level up your web dev game and build a portfolio that truly turns heads, stay with me till the very end, because I'm breaking down every step, every animation, and every detail to make sure you can follow along easily and build this masterpiece yourself. If this helps you out, don't forget to hit that like button and share it with someone who's ready to level up their dev game. So, without further ado, let's jump in and start building. All right, team, as always, we're starting completely from scratch. First things first, let's create a new folder on your desktop or wherever you like. Now, drag and drop that empty folder into your favorite code editor. For me, that's VS Code, but you can use whatever you like. Next up, let's open Google and search for Tailwind CSS. Click on the official Tailwind website. It should be the first result. Now, up at the top left, click on that version dropdown and let's switch it to a previous version because sometimes newer versions have breaking changes, and for this tutorial, we'll stick to a stable, familiar version. Great. Now use the search bar at the top of the Tailwind website and search for Vite. You should see a result saying install Tailwind CSS with Vite. Click on that. Perfect. Now we're on the guide page. The first thing it shows us is a command to create a new project using Vite. Copy that command. All right, now open the terminal in your code editor. Paste that command you copied. But we don't want Vite to create a new folder. We want all our files to live directly inside the folder we already created. So when we run the command after Vite at latest, add / like this. This / just means, hey, create the project inside the current folder, and hit enter. The terminal will now ask us a few things. 1, package name. Just press tab to accept default and enter. 2, select a framework. Move down and select React. 3, select a variant. Choose JavaScript, not TypeScript. And that's it. Now, one last setup step. Run this command, npm install. This installs all the dependencies that Vite and React need to get the project running. Wait for a few seconds while it installs everything. Now, Vite has automatically created a project structure for us. All right, moving on. The next step is to install Tailwind CSS into our Vite project. First, let's head back over to the Tailwind CSS website. Here, you'll see there are 2 important commands we need in order to set up Tailwind properly. Let's quickly understand what they do. The first command is used to install 3 essential packages into our project. First, it installs Tailwind CSS, which is the main library providing all the utility classes we'll be using. Second, it installs PostCSS, which is a tool that helps Tailwind process and transform our CSS behind the scenes. And third, it installs Auto-Prefixer, which automatically adds the necessary vendor prefixes so our styles are compatible with all modern browsers. After that, we have the second command. This command is used to initialize Tailwind inside our project, and it will automatically generate 2 important configuration files for us. One is the Tailwind config file, which allows us to customize Tailwind settings according to our project's needs. And the other is the post-CSS config file, which helps Vite know how to handle the CSS processing. Now let's go ahead and copy both of those commands. Open the terminal, paste them in, and hit enter. Let's give it a few seconds to finish installing. Once that's done, you'll see that the 2 configuration files have been created for us. That means Tailwind has been successfully initialized. Now we need to configure the template paths, so Tailwind knows where to look for our class names. Next, we'll copy the updated configuration from the Tailwind documentation. We'll open the Tailwind configuration file. Inside, you'll see some default content. Let's go ahead and delete everything inside that file. and paste it in. This updated setup will tell Tailwind to scan all our HTML files and all the JavaScript files inside the source folder, ensuring it picks up all the classes we use. Once that's done, the final step is to set up our main CSS file to work with Tailwind. We'll copy 3 simple Tailwind directives. Inside the SRC folder, you'll find a file called index.css. Let's open it up and, just like before, delete everything inside to start fresh. Then, paste them into the file. These directives are what bring in Tailwind's base styles, reusable components, and all its utility classes. And just like that, Tailwind CSS is fully installed, configured, and ready to go in our Vite project. All right, now that we've set up Tailwind CSS, it's time to run our project and make sure everything is working properly. To do that, let's open our terminal and run the command that starts the development server. Once you run it, you'll see a local server link appear in the terminal. Simply hold Control and click on the link to open up the online version of your project in your browser. Perfect. If everything is working fine, you should see your basic React app running. We want to make sure Tailwind CSS is actually working in our React setup. To do that, we're going to use a little test straight from the Tailwind CSS documentation. Let's go to the app.jsx file, which lives inside the SRC folder. Once we're inside that file, we delete everything that's already there. Then we paste in a basic example from Tailwind's own docs. This code simply returns a piece of text that says "Hello World," bold and underlined. That's it. That confirms our Tailwind setup is connected and functional. Now let's clean up the folder a bit. Inside that same SRC folder, we'll notice a file called app.css. We're not going to use this file because all of our styles will live inside Tailwind's utility classes and shared global styles. So we go ahead and delete app.css. No need to keep unused files around. Now inside the app.jsx file, let's delete this h1 element and add a fragment instead. This fragment will contain our component functions later. But before we create our first component, let's navigate to our index.css file. Right below the Tailwind directives, we'll define some basic styles for our web page's body. First, we apply overflow X hidden to prevent any horizontal scrolling in case something accidentally goes off screen. Then we set the font family to Arial, Helvetica, Sans Serif, which gives us a clean and readable look across all platforms. Next, we remove all the default spacing around the body with margin 0 and padding 0. We also make sure the body takes up the full width of the screen by adding width 100%, and we use position relative, which will be useful when we start positioning elements inside the page. Lastly, we give our site a dark theme by setting background color black, and we make all the text white with color white, so it stands out clearly on that dark background. Up next, we'll dive into creating our first component and bring this app to life step by step. So open the source folder, and inside it, create a new folder called Components. This is where we'll keep all the separate building blocks of our website, like the header, the footer, or any reusable UI sections. It helps us stay organized and makes the project easier to manage as it grows. Inside this new Components folder, let's create our very first component file and name it header.jsx. To quickly set up a basic React component structure, just type RAFCE. This stands for React Arrow Function Component Export, and it automatically writes the full component function for us. If typing RAFs doesn't do anything, that means you probably don't have the ES7 React Snippets extension installed in your VS Code. To fix that, open the Extensions panel from the left-hand sidebar, search for ES7 React Snippets, and click Install. Once that's done, delete anything in there and try typing RAFs again. Now it should generate the entire function component for you. At this point, your header component is working and returns a simple div with the word header inside it. But if you check your website in the browser, you won't see it showing up yet. That's because we haven't actually added the component to our main app. So let's go back to app.jsx. Right at the top of the file, we'll import the header component we just created. Then, inside the React fragment, the invisible wrapper we added earlier, we'll place the header tag. Now when you hit save, head back to the browser, and you should see the word header displayed on the page. Now let's go back to the header.jsx file and start designing it. The first thing we want to do here is remove that import React from React line at the top. We no longer need this in the newer versions of React, so let's clean that up. Next, inside the return statement, we'll swap out the default div element and replace it with a header element instead. Now let's style this header element using Tailwind CSS. We'll give it a class name and apply a few key utility classes. Absolute positions it right on top of the page layout. WFull makes it stretch across the entire width of the screen. Z50 ensures it stays on top of other elements. And finally, Transition All, along with Duration 300, adds a smooth transition effect in case we animate or change any styles later on, like shrinking it on scroll. Now, inside this header, the first thing we want to create is a div element. This will act as the container that holds all the elements we'll be adding to our header, like the logo, some navigation labels, maybe social icons, and eventually a Hire Me button that will trigger a contact form. Just to be clear, that contact form will be built separately and won't be inside this div. Before we add any content, we'll give it a class name and use a few Tailwind classes to control its layout and spacing. Container sets a max width and centers the content. MX Auto horizontally centers the container with auto margins. PX4 adds padding left and right, 1 rem. SMPX6 increases padding on small screens and up. LGPX8 adds even more padding on large screens. Flex turns the container into a flexbox layout. Items Center vertically centers all child items. Justify Between pushes items to the far left and far right. That's it. Now, inside this div, the main container for our header, let's create our very first element, the logo. We'll start by creating a div to hold the logo area, and we'll give it a class name with 2 simple Tailwind classes. Flex, which lays out the inner elements side by side in a row, and Item Center, which makes sure everything inside is vertically centered. Next, inside this logo wrapper, we'll add another div. This is where we'll display a single letter, for example, M, as a styled icon. You can customize this letter to match your brand or initials. Now let's style this inner div step by step. H10 sets the height to 2.5 rem. W10 makes the width the same. Rounded XL rounds the corners heavily. BG gradient to R sets up a background gradient that goes from left to right. From gray 500 starts the gradient with a medium gray. To gray 100 ends the gradient with a lighter gray. Flex turns this small box into a flex container. Item Center vertically centers the text inside. Justify Center horizontally centers it. Text Purple 600 makes the text color a bold purple shade. Font Bold gives the letter extra weight so it stands out. Text XL sets the font size to extra large. MH3 adds a little space on the right so there's breathing room before the next element. Now, just below that letter box, we'll add a span element. This is where we'll put your name or brand name. Again, let's style it one step at a time. Text XL, font bold, BG gradient to R sets up a gradient for the text. From gray 300 starts the gradient with a soft gray. To gray 100 ends with an even lighter gray. BG clip text clips the background gradient so it only appears inside the text. Text transparent makes the actual text invisible, which allows the gradient to show through. Oh, one quick fix. I forgot to set the height for the main container div of our header earlier. We need to make sure it has a consistent height across screen sizes, so let's add these 2 classes to it. H16 for a height of 4 rem on small screens, MD-H20 to increase that height to 5 rem on medium screens and up. And that's it. Great job. Let's move on to the next part. Now, before adding the rest of our header elements, we're going to bring our logo to life with a smooth reload animation using a library called Framer Motion. Let me explain what Framer Motion is, especially if you've never used it before. Framer Motion is a powerful animation library built specifically for React. It makes it super easy to add animations to your components, whether it's fading in, sliding, scaling, or even complex gesture-based animations. What's great is that it's built to work naturally with JSX, and it uses simple props to define animations. No complicated setup, no manual keyframes, just clean and smooth animations with minimal code. So if you're brand new to Framer Motion, no worries. I'm going to walk you through it step by step. The first thing we need to do is install it. So let's open the terminal. Before we can install anything, we have to stop our React app from running. You can do that by pressing Ctrl-C inside the terminal. Now to install the library, we type the command npm install framer-motion. Then press enter and let it finish installing. Great, once it's installed, we're ready to use it in our component. So now let's go back to our header.jsx file. This is where we'll add our animation. At the top of the file, we'll import the animation tool we need. Type import motion from Framer Motion. That's it. Now Framer Motion is ready to use in this component. Next, we need to tell React which element we want to animate. In our case, we want to apply the reload animation to the entire logo, both the letter and the brand name. So we take the outer div that wraps our logo and simply change it to a motion.div. That's all you need to do to make it animatable. Just don't forget to also change the closing tag at the end to match. It should say motion.div. Now that this element is powered by Framer Motion, we can define the animation using some special props directly on the tag. Let's break down the animation we're applying. Initial equals opacity 0, x minus 100. This means the logo starts off invisible and positioned 100 pixels to the left. Animate equals opacity 1, x 0. This brings it back into place and fades it in smoothly. Transition equals type spring. This tells Framer Motion to use a spring animation. A spring has a natural bounce. It moves quickly and then slows down like a real physical object. Stiffness 100. This sets how tight the spring is. Higher stiffness means the element moves faster and feels snappier. If we made it, say, 300, it would snap really fast. Damping 25. This controls how much the animation slows down at the end. Delay 0.3. This makes the animation wait 0.3 seconds before it starts. Duration 1.2. This is the overall length of the animation in seconds. So here, the whole thing takes 1.2 seconds to complete. That's it. These small values might look simple, but together they control the entire vibe of your animation. We've now defined a reload animation for the logo. But if you reload the page right now, the animation might not work. That's because earlier we stopped the development server to install Framer Motion, so we need to start it again. Just open the terminal and run the command npm run dev. Now reload the browser, and boom, you'll see the logo smoothly slide in and fade into place. Nice work. Let's keep building from here. Next, right below the container div that holds our logo, we're going to create the navigation bar, specifically for desktop devices. So let's go ahead and add a new div for that. We give this div a class name and apply the following Tailwind styles. First, LG Flex. This means the navigation will be visible only on large screens and above, like desktop monitors. Before that breakpoint, it stays hidden. Then we add hidden, which hides the element by default. So until the screen size reaches the large breakpoint, this navigation won't show up. Next, we add space x8. This adds horizontal spacing between each item inside the navigation. Now, inside this navigation div, we want to define our list of navigation labels like home, about, projects, experience, and contact. And instead of writing them manually one by one, we'll use the map method to loop through them dynamically. So we create an array with those label names, and we use the map function to go through each item. For every label in the array, we're going to return an anchor tag. That's the clickable link. Each label will be wrapped inside its own A element. We also add a key attribute with the value set to item. And here's how we'll style that link. We give it a class name with several utility classes from Tailwind. Relative, text gray 800, dark text gray 200, hover text violet 600, dark hover text same hover effect but for dark mode. Font medium. Transition colors. This enables smooth transitions between colors instead of changing instantly. Duration 300. The transition duration is 300 milliseconds, just enough to feel nice and smooth. This class is used when we want to target hover or focus states of nested elements. Even though we're not using it immediately, it gives us flexibility to add animated underlines or icons later. And right inside this anchor tag, we're going to display the list of the navigation items. To do that, we simply insert item inside the anchor. This dynamically injects each item's text as the map function loops through the list, so each anchor will automatically display the correct label without us having to write them out manually. Now, to enhance this a bit visually, just under the text inside the anchor, we'll add a span element that creates a nice animated underline effect when we hover over each link. This span is used to create a subtle animated underline effect that appears when we hover over a navigation link. It's a small detail, but it gives our header a really professional feel. We set the initial width of the span to 0, so the line is hidden at first. In Tailwind, h0.5 equals 2 pixels, which is just enough to create a clean, thin line. BG Violet 600, this sets the color of the underline. Group Hover W Full, this is where the animation magic happens. Because the parent anchor has the group class, we can listen for hover events on that group. When we hover, this class changes the width of the span from 0 to 100%, making the line slide across the text. Transition All. This enables smooth animation for all properties being changed. Duration 300. This sets the animation duration to 300 milliseconds, which makes the underline appear quickly but smoothly. So, when someone hovers over a nav item, this span expands from the left, from 0 width to full width, creating a beautiful animated underline. Now, the final thing for our navigation section on desktop devices is to add a smooth reload animation to each nav link. So the first step is to convert our regular A tag into a motion.a tag. That gives us access to animation props. We define the animation like this. We start with initial equals opacity 0, y minus 20. This means that when the page first loads, the nav item is fully transparent and shifted 20 pixels above its normal position. It's hidden and slightly out of place. Then we have animating opacity 1, y0. This is the end state of the animation. The element becomes fully visible and moves into its natural spot on the page. So as the animation runs, it fades in and drops into place. Now let's break down the transition. Type spring. It makes the drop feel more lifelike and smooth. Stiffness 100. This controls how tight or snappy the spring is. Damping 20. This controls how much the motion slows down before stopping. Delay 0.7 plus index 2. This part staggers the animation for each nav item. The first one starts at 0.7 seconds, the next one waits an extra 0.2 seconds, and so on. That means each link fades and drops in just a little after the one before it, creating a clean cascading effect across the nav bar. That was it for the nav section of our desktop layout. Great work. But before we move on to the next part, let's quickly make one final adjustment. The main container div that's holding our navigation, let's change that from a plain div into a nav element instead. Great. Now let's build the next section of our header. Right below this nav element, we're going to start a new section, and we'll do that by creating a div. This section will be dedicated to other header elements like social icons or extra buttons. Once we've created that div, we give it a class name and apply the following Tailwind styles. First, we add MD Flex. This means the div will only be displayed as a flex container starting at the medium screen size and above. On smaller screens, it'll stay hidden. Then Item Center. Finally, we use space x-4. This adds horizontal spacing between each child element. Now, right inside this div, we're going to create an anchor tag. This will be the clickable area that holds our first social icon. For the icons themselves, we'll use the React Icons library. Before we can use this library, we need to install it into our project. So let's open the terminal, and first, stop the project from running by pressing Ctrl-C. This just pauses the development server. Then type the command npm install React Icons and hit enter. This will download the library and add it to our node modules. Once the installation is finished, we can go ahead and run the project again with the command npm run dev. so our changes are reflected live. Now that the library is installed, let's bring in our first icon. Scroll to the top of the file where all our imports are. We'll import the GitHub icon from the feather icon set that comes with React icons. So we write import FidethHub from React icons phi. The phi stands for feather icons, and GitHub is the specific icon we're pulling in. Great. Now scroll back down to the anchor tag we created. Inside this anchor tag, we're going to place the GitHub icon by just writing the component like a self-closing tag. It's really that simple. Now, to control the size of this icon, we give it a class name and apply Tailwind's W5 and H5 classes. These set the width and height of the icon to 1.25 rem or 20 pixels, which is a good clean size for UI icons. Now we move on to styling the anchor tag itself. We give the anchor tag a class name and apply the following Tailwind utility classes. This tells Tailwind to animate the color change over 300 milliseconds, which gives it a smooth, polished effect. All right, now, before we start adding more icons, let's make the one we already have a bit more fun and interactive by using Framer Motion to apply a nice little reload animation. So the first thing we're going to do is take that anchor tag, the one wrapping our GitHub icon, and convert it into a motion.a tag. That way we can animate it. Now we're going to define the animation using three simple properties: initial, animate, and transition. Initial equals opacity 0, scale 0.5, means the icon will start off completely transparent and slightly smaller than its final size. Animate, opacity 1, scale 1, tells it to end at full visibility and normal size. And transition equals delay 1.3, duration of 0.8, just controls the timing. So the animation waits 1.3 seconds after the page starts loading, and then takes 0.8 seconds to complete. Next, let's expand this section by adding two more icons, one for Twitter and one for LinkedIn. Easiest way to do this is to copy the whole motion anchor tag we just created and paste it twice right below it. Then, to update the icons, we first scroll up to the top of the file and import them from the React-Icons library. We'll import FitTwitter and FLinkedIn, just like we did earlier with GitHub. Now we scroll back down, and in each of the new anchor tags, we simply replace the GitHub icon with Twitter in one and LinkedIn in the other. And that's it. All three icons are styled consistently and have the same smooth animation when the page reloads. Next up, we're going to add a Hire Me button that'll be used to open up our contact form. Let's get into that. This will be a call to action that later links to our contact form. So just below the container div that holds all our social icons, we're going to create a button element and type Hire Me inside it. Next, it's time to style it. ML-4 adds some left margin so the button isn't stuck to the icons. PX4 Pi 2 gives it padding on the X and Y axes to make it feel clickable and spacious. Rounded XL gives it soft, rounded corners. BG gradient to R from gray 400 to gray 100 creates a subtle horizontal gradient for the background. Text violet 700 colors the text in a strong violet. Font bold makes the text stand out. Then for hover effects, we use hover from violet 700, hover to purple 700 to make the background shift to a bold purple gradient on hover. Hover text white makes the text white when hovered. Finally, transition all duration 500 ensures all these changes animate smoothly over half a second. Now the button looks stylish and inviting. To keep things consistent with the rest of our header, let's give it a reload animation using Framer Motion. So, just like we did with the social icons, we'll convert our regular button into a motion.button. Now let's define the animation. We begin by setting the initial state. This is how the button looks when the page first loads. Opacity 0 makes the button invisible at first. Scale 0.8 makes it appear slightly smaller than its final size. Then we define the animate state, which is the final look we want the button to have once the animation is complete. Opacity 1 means fully visible. Scale 1 means it scales up to its normal size. Next comes the transition, which controls how the animation moves between the initial and final states. Delay 1.6 means the animation will wait 1.6 seconds before starting. Duration zero point 0.8 means the animation will take zero point 0.8 seconds to complete. Type spring gives the animation a nice natural bounce. Stiffness 100 determines how firm the spring is. Higher values make it snappier. Damping 15 controls how much it slows down at the end, so it doesn't keep bouncing, just gently settles in place. It looks like I made a small typo here. Always be careful. Even a minor typo can prevent your project from running correctly. Now, if we reload the page, we should see the smooth loading animation applied to all of our header elements. All right, so now we're moving on to building the mobile navigation, which is going to be a sidebar that slides in and out when the user taps on a menu icon. Before we dive into building the actual sidebar, let's start by placing the menu icon itself. We're going to add this icon right below our Hire Me button. We set the icon to hidden on medium screens and above, so it only appears on smaller viewports. Then we give it flex, so it displays correctly, and align the items to the center. Now, to make the sidebar open and close, we need a way to track whether it's visible or not, and for that, we'll use React State. So let's scroll up to the top of our component, just above the return statement. Here, we'll declare a simple piece of state using the useState hook. We call this state isOpen, and we set the initial value to false, because the sidebar should be closed when the page first loads. If you're using useState, we need to make sure it's imported. So scroll up and just below your other imports, let's add this line. Import useState from React. Without this import, React won't know what useState is, and your project will break. So always double check for these small things. Right below the state we just defined, we're going to add a small helper function. We'll call it toggle menu, and all it does is flip the current value of isOpen. If it's false, it becomes true. If it's true, it becomes false. This way, every time the user clicks the menu icon, we toggle between opening and closing the sidebar. Super simple, super effective. Next, to actually show different icons for opening and closing the menu, we need two icons, one for the hamburger menu and one for the close icon. These come from the React Icons library, specifically from the Feather Icons pack. So up at the top, let's import both FiMenu and Fix. Great, now scroll down into the JSX, and inside the container div, where we want our mobile menu icon to live, we're going to place a button element. This button will control the sidebar. Inside the button, we use a simple conditional. We check if isOpen is true. If it is, we show the close icon using Fix. Otherwise, we show the hamburger menu using FiMenu. Both of these icons are given a class that sets their width and height to 6, so they're perfectly visible and touch-friendly on small screens. Finally, let's style the button itself. We'll give it a class that sets its text color to gray. The next important step is to make this button do something. Specifically, we want it to open and close our sidebar when clicked. To do that, we simply add an onClick attribute to the button and connect it to the toggle menu function we defined earlier. So every time the user taps on this button, it flips the isOpen state, and based on that state, our sidebar will either appear or disappear. Now let's make this button feel more alive, and for that, we're going to use Framer Motion. We start by converting the regular button tag into a motion.button, which gives us access to animation props. Then we add a simple interaction animation using while tap. This animation scales the button down to 70% of its size when tapped, giving it a nice press effect. Kind of like it's responding to your finger. It's subtle, but it adds a nice touch of polish and professionalism to the user experience. Great. Now that our toggle button is working perfectly, it's time to build the actual mobile menu, the part that slides down or appears when the user taps on that icon. So right below the main container div, the one that wraps all of our header elements, including the logo, desktop nav, and menu icon, we're going to add a brand new div. This one will serve as the container for our mobile navigation menu. We'll give it a class name that hides it on medium screens and up using mdhidden, so it only shows on small devices. We also give it overflow hidden to ensure content doesn't spill out during animations, and we set a background color, white. Next, we add Shadow Elf for a soft drop shadow effect, and we apply padding on the X and Y axis using px4 and pi5 to give the content inside some breathing room. Finally, space Y5 is used to add vertical spacing between all the elements inside the menu. So we're now inside the mobile menu container. Inside that, we're going to create a nav element. This will hold our navigation links, just like we did for the desktop version. We give this nav a class name that sets it up as a vertical flex container by using flex and flex call. And to make sure there's some space between each item, we add space Y3, which creates a nice consistent vertical gap between the links. Now that our nav container is ready, we want to fill it with the same navigation items we used for the desktop menu. So we scroll up, find that list of labels, home, about, projects, experience, and contact, and simply copy that same array down here into the mobile section. Then, we use the map method to loop through that list. For each item in the array, we generate an anchor tag. This anchor will serve as the actual link that the user can click on. We make sure to give each one a key, which is important for React's performance and internal tracking. And of course, we also include the label itself inside the anchor, so it displays the name like home or about. Now let's give this anchor tag a class name and apply the following styles to it. We'll start with text gray 300, then we add font medium to make the text slightly bold, and finally ppi2 adds some vertical padding, which creates a nice space between the links and makes them easier to tap on mobile devices. Also, let's give it an on-click attribute and pass in our toggle menu function. This means that when a user taps on any of these nav links, the menu will automatically close. We will later configure toggle menu to close the sidebar when it is clicked, but for now, this setup is perfect. Great. Now, before we add other elements to our mobile menu, we want our menu to open with a smooth animation. So let's convert this main container div to a motion.div. That allows us to animate its appearance using Framer Motion. Then let's define the animation. First, we set the initial state to opacity 0 and height 0, which makes the menu hidden and collapsed by default. For the animate state, we use the isOpen variable. What this means is if our sidebar is open, we want it fully visible, so opacity is 1. If it's closed, we set opacity to 0 so it fades out. Next line, height is open. Here we're saying if the sidebar is open, we want it to automatically grow to fit the content, so we use auto. But when it's closed, we collapse it to height 0. And that's the closing brace. Finally, we apply a transition with a duration of 0.5 seconds. That's half a second, which creates a smooth and pleasant open and close effect for the menu. Great. Let's move on to creating the next element of our mobile menu. So now, right below this nav element, let's create a new div. This one's going to contain our social icons and the Contact Me button. First, we'll give it some spacing and a visual break by applying pt-4 for padding on top and a top border using border T. We'll go with border gray 200. Now inside this section, we'll nest another div. This one will hold all of our social icons. We want them to sit in a row, so we'll set it to flex, and we'll space them out evenly by adding space x5. All right, let's add our first icon. We'll use an anchor tag, and inside it, we'll place the GitHub icon component. Give the icon a class to control the size, width, and height, both set to 5. Also, let's make the color gray so it blends nicely with the rest of our design. Now we need 2 more icons, so we'll just copy this anchor tag and paste it twice right below. Then we'll swap out the icon components, one for Twitter and one for LinkedIn or whatever social platforms you're using. This way we stay consistent in layout but customize the icons. Next, right below that icons container div, we're going to add our Contact Me button. So let's create a button element. We'll style it with MT4 for margin on top, block to make it full width, and then padding on both axes using px4 pi2. We'll round the corners with rounded LG, and for the background, we'll go with a gradient from violet 600 to violet 400. Set the text to bold for emphasis, nice and readable. Now let's add an on-click to this button. We'll call toggle menu when it's clicked. That way, the menu closes automatically after the user clicks Contact Me. We're wrapping this in a function because later on, we're also going to add one more action here, opening the contact form. And yes, that contact form is something we're going to build next, right inside the same header component. So let's start right below the closing tag of our motion.div, that's our mobile menu, and we're still inside the main header element. Right here, we're going to build our contact form, but before jumping into the actual JSX, let's set up the logic that controls whether the form is open or not. First, scroll up just above the return statement, and let's define a piece of state using useState. We'll call it contact form open and set its initial value to false. This state will track if the contact form should be shown. So we write const contact form open, set contact form open equals useState false. Super straightforward. When it's false, the form is hidden, and when it's true, the form shows up. Right below that, we're going to define two helper functions. First, open contact form. This will simply call set contact form open true. That means when this function is triggered, the form becomes visible. Then we define close contact form, which does the opposite. It sets the state back to false, hiding the form again. So with just these two functions, we now have full control over showing and hiding the form. Now that we have this logic, we can scroll back down and use it in our component. We'll conditionally render the contact form based on whether contact form open is true. So when the user clicks the Contact Me button, it triggers open contact form, and that tells React to show the form. So right here, we're going to start rendering the contact form conditionally. What that means is we only want this form to appear when the contact form open state is true. So we start with a simple check using curly braces and the NNN operator. Basically, we say, if contact form open is true, then go ahead and render this contact form. Inside this conditional block, we open a div, and this will be the outermost container for the entire form. Now let's style this outer div. First, we want it to overlay the entire screen, so we use fixed to take it out of the normal document flow and fix it to the viewport. Insets-0 is a shorthand that stretches it from top to bottom and left to right, so it fills the whole screen. Next, to create a dark overlay behind the form, we add BG black/50, and then we use backdrop blur sem to give a subtle blur effect to the background, which adds a nice modern touch. We also need this overlay to be on top of everything else on the page. Then, we center the form inside the screen. We do that with flex, then item center to center it vertically, and justify center to center it horizontally. Finally, we use P4 to add some padding around the edges. So that's the structure and styling for the outer container of our contact form. So now basically if we click on the Hire Me button, we expect to see that blur effect covering the whole page, but it's not happening. And the reason for that is simple. We haven't yet hooked up our click event to the actual function that opens the form. So let's scroll to where we've defined our Hire Me button, and let's add an on-click attribute to it. In this case, we set it to run the open contact form function. This is the function we wrote earlier that sets the contact form open state to true, which in turn triggers our conditional rendering and displays the form. Now that we've added that, go ahead and try it in the browser. Click the button, and there it is. You should now see that full page blur effect appear. All right, that's working great. So let's keep going and build out the rest of the contact form inside this overlay. And before we even add any input fields or content, we want to test that our closing logic actually works. To do that, we'll add an on click and hook it up to the close contact form function we created earlier. Now let's go ahead and test it. Click on the Hire Me button, and you should see that blur effect appear. Now click anywhere on the page, and it disappears. All right, next step is adding some nice smooth animation for when this contact form appears and disappears. So the first thing we need to do is convert this outer container div into a motion.div. Then we'll define our animation settings. For the initial state, set the opacity to 0 so it's invisible. Then in the animate state, we bring it back to full opacity. Now for the exit animation, this is what happens when the form closes. Set the opacity to 0 and a slight duration to slow it down just a bit. That's it. Now it's time to add the actual elements inside our contact form. So inside this motion.div, let's create a new div that will hold all of our form content. We'll give it a class name and apply some nice Tailwind styles. We want a white background, soft rounded corners, a shadow for elevation, full width with a max width to keep it centered and readable, and some padding for breathing room. Now inside this container, we're going to create another nested div. This one will hold two things, an H1 heading that says Get in Touch, and a close button with an X icon to dismiss the form. So first, let's create our H1 and add a class name to it. We'll make the text large with text 2XL, bold with font bold, and we'll color it a light gray to match our theme using text gray-300. Right below the heading, we'll create a button element and insert the fix icon from React Icons inside it. This is the same X icon we used earlier in the mobile menu. We'll give this icon a class that sets its width and height to 5, and again, color it gray for consistency. Then, for the button itself, we'll attach the onClick attribute and hook it up to our closeContactForm function. So clicking this icon will hide the form. Next, let's style the div that wraps both the heading and the close button. We'll use flex to place them side by side, justify between to space them out, and item center to vertically align them. Finally, we'll add a bottom margin with MB4 to give the form some space before the next section. Before we move on, let's make the close icon pop just a little more by setting its font weight to extra bold. That'll make it visually stronger, easier to notice. Also, now that we have a proper close button, we can remove the temporary onClick equals close contact form we added to the outer container earlier. That's no longer needed. Perfect. Now we're ready to move on, and right below this section, we'll start creating our input fields for the contact form. First, we'll create a form element, and to space out each input vertically, we'll give it a class name of space y4, which adds consistent spacing between the children. Inside the form, let's start with the first input. For cleaner structure, we'll wrap each label and input pair inside a div. So inside this div, we'll first add a label element. We'll give it an HTML4 attribute set to name. The visible text of the label will be name. Now let's style the label. We'll give it a class name that applies block display so it sits above the input, TextSem to make the font size smaller, font medium to give it a medium weight, and color it light gray with text gray 300. Finally, we'll mbeam-1 to create a little margin below the label before the input field. Great, now right below that label, we'll create the actual input element. We'll keep the type as text since it's for a name, and set the ID to name so it matches the label. We'll also add a placeholder that says your name to guide the user. For styling, we'll give this input full width using wfull, some padding with px4 and py2, and a border using border and border gray 600 for a subtle outline. We'll round the corners with rounded LG for a soft modern feel. And to improve the focus experience, we'll use Focus Ring 2 and Focus Ring Violet 500 for a glowing effect, and match the border color with Focus Border Violet 500. Finally, we'll give it a dark background using BG Gray 700 to match the overall dark theme of the form. That's our first input, done. Clean, styled, and accessible. Now we need two more inputs, one for the user's email and another for their message. To keep things efficient, let's go ahead and copy the entire div that contains both the label and the input for the name field, and then paste it 2 times right below. Make sure everything is properly indented so it stays clean and readable. Starting with the second input field, we'll update the HTML4 attribute inside the label from name to email, and change the text inside the label to email so users know what to type. Then, inside the input itself, we'll change the type from text to email and update the ID to email so it matches. Lastly, update the placeholder text so it reads your email for clarity. Great. Now let's move to the third and final input field. First, change the HTML4 attribute in the label to message, and also update the visible text inside the label. Then replace the input element with a text area element. We no longer need the type attribute here because it's not an input, it's a text area. Instead, we'll add a rows attribute and set it to 4 to make it a good height by default. Change the ID to message to keep it connected to the label, and finally, update the placeholder text to say, "How can we help you?" to prompt the user. And that's it for the input fields. We now have one for the name, one for the email, and a message box, all properly styled and structured. Let's move on to the submit button. So we want to create the button right inside the form element, and we'll place it directly below the message input field. Let's go ahead and create a button element with the text send message inside it so users know what action they're taking. Now we style it by adding a class name. We'll set the width to full so it spans the container, and we'll give it some padding with px4 and py2 to make it comfortably clickable. For the background, we'll apply a gradient from violet 600 to violet 400 for a nice vibrant look. And we'll also add hover states that shift the gradient to deeper violet and purple tones to give it some interactivity. Add transition all and duration 300 so the hover effect feels smooth, and round the corners using rounded LG. Then we'll apply a subtle shadow with shadow MD and increase it on hover using hover shadow dash LG along with a violet tinted shadow for extra depth. Now to make it feel even more interactive, let's animate it. We'll convert this regular button into a motion.button so we can add motion effects. First, set the type to submit since this button is part of our form. Then we'll define two simple animations. While hover equals scale 1.03 to slightly scale the button up when the user hovers over it, and while tap scale 0.97 to give a subtle press down feel when the user clicks it. That's it. Now let's save and check it in the browser. When we hover or click on the button, it smoothly scales and gives that professional, polished feedback. Looks great. Let's move on. All right, great. Now let's add one more smooth animation to the container of our contact form. So first, scroll up to the div that wraps the entire form element. We're going to animate this container. So the first step is to convert this regular div into a motion.div. And don't forget, anytime you open with a motion.div, the closing tag at the bottom also needs to match, so update that one too. Now let's define the animation properties. For the initial state, when the component first mounts, we'll set the scale slightly down to 0.8, opacity to 0, and move it down a bit using Y30. Then for the animate state, when it's fully open, we scale it back up to 1, bring the opacity to 1, and move it to its original position with Y0. For the exit animation, when we close the form, we'll return everything back to how it started, scaled down, faded out, and pushed down again. To control the timing and feel of the animation, we'll add a transition object. We'll use a spring animation, which gives us a nice natural motion. We'll set the damping to 30 and the stiffness to 200 to get that snappy feel, and a duration of 0.8 for a smooth overall effect. Now, if you try opening the contact form, the animation feels great. But when we close it, it feels a little off, kind of abrupt. That's because React removes the element immediately on unmount, and the animation doesn't have time to finish. To fix this, we'll use a helper from Framer Motion called Animate Presence. So let's scroll up to our imports from Framer Motion, and here we'll import Animate Presence. Once that's done, scroll back down to the part where we conditionally render the contact form. Right here, wrap the whole thing, the contact form open section, with Animate Presence. Then, make sure to properly indent everything inside this wrapper so it stays clean and readable. Now, save your changes and try it again. You'll see the form fades out with that same smooth animation instead of just vanishing instantly. Much better, way more polished. All right, now remember, we already created a Contact Me button inside the mobile menu earlier, and just like the desktop Hire Me button, this one is also supposed to open the contact form when clicked. So let's go find that button. You'll see it sitting just above the contact form code in the mobile menu section. So inside the onClick attribute of this button, we call Open Contact Form to pop up the contact form. This way, both actions happen smoothly in sequence when the user taps that button. Everything's synced up, and with that, we can say the header section is complete. That was a pretty detailed section, and there were quite a few moving parts between the navigation, mobile toggle, animations, and contact form. But now everything's working beautifully. Oh, and by the way, I just noticed there's an import statement I accidentally left in the file, so let's go ahead and remove that to keep our code clean. Now let's move on to the next big piece, the hero section. So we'll go into our components folder and create a new file called herosection.jsx. Inside that file, let's use the handy shortcut RAFCE. This stands for React Arrow Function Component Export. Next, we want to bring this new hero section into our app. So open up your app.jsx file, and at the top, import the hero section component. Then go down into the return statement and add the hero section right below the header component. Cool. Now the hero section is wired into our app and ready for content. Let's go back into the hero section file for a little cleanup before we start building. First, remove that div, we won't be using that, and also get rid of the import React from React line at the top. Inside the return statement of our hero section component, we're going to create a section element. This will act as the main wrapper for the entire hero area. Let's style this section using Tailwind CSS. We'll make it take up the full height of the screen with HScreen and give it a background gradient, going from violet at the top to black at the bottom. That creates a smooth, dark, modern look. Then we'll use Flexbox to lay out our content. We want the layout to switch between row and column depending on screen size, so we apply XL, Flex Row, Flex Col Reverse. This means that on extra large screens, the content will sit side by side in a row, but on smaller screens, it will stack vertically. And in reverse order, the model will come first, then the text. Next, we center the items vertically with items center and space them out horizontally with justify between, so they're pushed to the sides when there's space. For padding, we use LG PX24 for large screens and PX10 for smaller ones. This gives our content room to breathe on both sides. We also add relative to position any absolute elements later on if needed, and overflow hidden just in case any animations or elements spill outside. That keeps everything contained within the section. Now the hero section is ready to be split into two main parts, the left section for the text and the right section for our 3D model. Let's start with the left side. We'll create a div inside this section. This div will hold all of our introductory text elements. Inside this left div, we start with an H1 element. The text will say building fast, and on the next line, reliable results. We'll use a line break tag, BR, to split the text into two lines. Now, for styling this heading, we want it to stand out. For size, we use responsive text sizes, text 5XL on small screens, MD text 7XL on medium screens, and LG text 8XL on large screens. This ensures it scales nicely across devices. So we give it a bold font with font bold, a high Z index with Z10 to keep it layered on top of anything behind, and some spacing below it with MB6. Now we've got a strong, bold intro heading in place on the left side of our hero section. So before we move on to the next text element, we're going to add a simple but smooth entrance animation to our heading using Framer Motion. To do that, we first need to import Motion from the Framer Motion library. So right at the top of our file, we add the line that brings in motion from Framer Motion. Once we've got that, we go back down to our H1 element and we convert it to a motion.h1. That tells Framer Motion to treat it as an animated element. Now let's define the animation. When this heading first loads, we want it to fade in and slide up into place. So we use initial to set its starting state with opacity 0 and Y80, which means it starts off completely transparent and pushed down by 80 pixels. Then we use animate to bring it to opacity 1 and Y0, making it fully visible and back in its normal position. For the transition, we go with a spring type animation that gives us a natural bounce and makes the motion feel alive. We set a stiffness of 40 and a damping of 25 to keep it soft and smooth. We also add a delay of 1.3 seconds to let everything else settle first before the text appears, and we set the duration to 1.5 seconds so the animation has time to flow. Looks great so far. Now let's go ahead and add the next text element right below this heading. a paragraph. This will be a short description text where you can introduce yourself, your profession, or what you do. You can completely customize this part based on your own status or brand. And for styling, we give it a class name with the following Tailwind styles: Text XL for small screens, MD Text 1XL for medium screens, and LG Text 2XL for larger screens, so it scales well. We make the text color a soft purple using Text Purple 200 and limit the width with Max W2XL to keep it clean and readable. Now, just like our heading, we want this paragraph to have a smooth reload animation as well. So we convert the P into a motion.p. Then we define its animation using the same pattern. This time we delay it a bit more to 1.8 seconds so it comes in just after the heading and keeps the flow feeling natural. The duration stays the same at 1.5. All right, now we're at the final step for the left section of our hero, and that's adjusting its position so everything feels well balanced across the screen sizes. To do that, we add a class name to the container div of the left content and set it to Z40 XLMB-0 MB 20%. This makes our layout responsive and visually clean. Now let's shift to the right section of our hero, where we're going to embed a beautiful 3D model. For this, we'll be using a powerful and beginner-friendly tool called Spline. If this is your first time hearing about Spline, let me give you a quick intro. Spline is a free web-based 3D design tool that lets you create, animate, and export interactive 3D models for the web. It's super intuitive, perfect for both beginners and advanced designers. The best part is it integrates seamlessly with React, which means we can directly embed interactive models right into our website with just a few lines of code. To get started, head over to spline.design. That's their official website. If you don't already have an account, just sign up. It's completely free. Once you're in, click the Get Started button to enter the editor. Now, from the left-hand dashboard, you'll find a Community tab. Click on that. And here's where the fun begins. You'll see a huge collection of amazing models created by other Spline users. Browse around, and when you find something you like, you can click on it and remix it, meaning you can customize that model as you like, then export and use it in your project. But to make things easier for this tutorial, I've already prepared a 3D model for you. It's clean, optimized, and ready to go. You can find the link to that model down in the description box of this video. Once you open that link, you'll be taken to a page with the model preview. At the top, you'll see a duplicate file button. Click that to clone the model into your own workspace. Now you're inside the Spline editor. Important note here, once you're inside the editor, try not to move or zoom the camera. Any small adjustment can change the position or size of the model when it shows up in your project, and that might throw off your layout, so just leave the model as it is. Now, if you're interested in learning more about how to design your own 3D models in Spline, I've got a tutorial for that on my channel. It's part of a gaming UI project where we walk through everything step by step, so definitely check that out after this one. All right, now let's walk through how to actually bring that beautiful 3D model from Spline into our web page. And honestly, it's a really simple process, even if you've never worked with 3D models before. Let's start by checking how the model will look across different devices. To do that, go to the top menu and click on the View option. This gives us some handy previews of how our model behaves on phones, tablets, and desktops, so we can be sure it's responsive and not cutting off anywhere. Once we're happy with that, head to the Export button right at the top. This is where we get the actual link and code to embed the model into our React project. Now under the public URL section, there's a little area labeled Play Settings. In here, you'll find options like removing the Spline watermark, but keep in mind, that's only available in the paid version. And since we're sticking with the free tools for now, because we like to not pay for stuff, we'll ignore that for now. However, there are a few settings here you should pay attention to. You can enable or disable zooming, panning, and background transparency. things that can change how your model feels when it loads. Just make sure your settings match mine as I show in the video. And once that's done, go ahead and hit the Update Public URL button at the bottom. On the right panel, you'll see a code export section. Click on that, and up top, there's a dropdown for frameworks. Make sure it's set to React, since that's what we're using in this project. Then just wait a second. The code will generate for you. Once the code is loaded, we don't need the whole thing. We're only interested in the line that contains the actual spline/component. So copy that line, and now switch back over to your code editor. Scroll down to the area right below the left section's div. That's where we'll paste the spline element. Paste it in, save the file, and oops, everything breaks. That's totally expected. The reason our app crashes now is because we haven't actually installed the Spline library into our project yet. So open up your terminal, and if the development server is still running, stop it first by pressing Ctrl+C. Then run the command npm install at splinetool/react spline. Hit enter and wait for the installation to complete. Once that's done, start your app again by typing npm run dev. Now, back in the component file where we added the spline element, we need to import the library so that React knows how to render it. Scroll to the very top of your file and add this line. Import spline from @splinetool/react-spline. Save the file again, and now if you go back to your browser and refresh the page, the 3D model appears. It's fully interactive, smooth, and it looks amazing sitting in the right section of our hero layout. And just like that, we've successfully embedded a real-time 3D model into our website using Spline and React. No complex WebGL code, no headache. All right, now let's take care of that little watermark that appears with our Spline model. Since we're using the free version of Spline, the watermark is going to stay. We can't completely remove it unless we upgrade to the paid version. What we're going to do is give our Spline element a class name. So first, we add the class and apply absolute positioning. This lets us manually control exactly where the model sits within the section. Next, we use XL right 28%. This moves the entire Spline canvas far to the right only on extra large screens, basically shifting the watermark out of view while keeping the model itself centered and visible. It's a little hacky, but it works beautifully on desktops. However, the position of the 3D model on smaller screen sizes should be slightly shifted upward for improved layout and visibility. So to handle that, we layer on a few more responsive utility classes. We set right 0 to reset the right positioning on smaller screens. Then we apply top 20 cent to nudge the model upward a bit so it stays nicely balanced vertically. Finally, we use LG top 0 to bring the model back to normal top alignment on large screens and up. Now, once you save and head back to your browser, open up your device preview tools, or just manually resize the window, and you'll see that the model looks clean and well-positioned across all screen sizes. Now we've arrived at the final touch for this project, and it's going to be a fun one. We're going to add a custom cursor to our website, and to make it feel smooth and interactive, we'll animate it using GSAP. Before we jump into the code, let me quickly explain what GSAP is for anyone who's new. GSAP, which stands for Green Sock Animation Platform, is a super powerful and flexible JavaScript animation library. It's used by professionals all over the web to create high-performance animations, from simple fades and slides to complex scroll effects, 3D transformations, and even full animation timelines. What makes GSAP stand out is how smooth and performant it is, even with really complex animations. It works seamlessly with vanilla JavaScript, but also plays nicely with frameworks like React, Vue, and others. Now, in our case, we'll use GSAP to control the behavior of a custom cursor, basically a small circle or shape that follows the user's real mouse pointer around the screen, but with smooth motion and a bit of delay. This kind of effect gives your site a more modern and polished feel, and GSAP makes it really easy to handle the logic behind the motion. The way we'll set it up is, we'll create a separate component for the custom cursor. So first things first, we head into our components folder and create a brand new file. We'll name this one custom cursor JSX. Now inside this file, we're going to use a shortcut to create our React component. So I'm going to type RAFCE, which is just a snippet that quickly generates a React arrow function component with export. With that in place, we now want to make sure this component is actually showing up in our app. So let's open the app.jsx file, and right at the top, we're going to import the custom cursor component, just like we would with any other component. Once that import is done, we'll add our custom cursor/component right below the hero section. All right, let's switch back over to the custom cursor.jsx file. You'll see an unnecessary React import at the top. We can remove that because we're using the latest version of React. Then, inside the return statement, we currently have a default div. We don't need that either. Instead, we'll replace it with a fragment, which is just a shorthand way of grouping JSX elements without adding any extra HTML to the DOM. All right, let's begin building the core logic behind our custom animated cursor using React. To kick things off, the first thing we need to do is create references to the cursor elements that we'll be animating. These references will allow us to directly access and manipulate the actual DOM elements, which is necessary when working with animations. So let's start by going to the top of our component file and importing two hooks from the React library. We need useRef, which helps us reference elements in the DOM, and useEffect, which allows us to run side effects like animations when the component mounts. Once those are imported, we'll scroll down inside the component, right above the return statement, and define our cursor references. We're going to define two useRef hooks. The first one will be called cursorRef, and this will point to our main cursor element. The second one will be cursorBorderRef, which will reference a second element, usually a larger border circle that follows the main cursor for that smooth trailing effect. By setting up these refs now, we're laying the foundation to animate them later using GSAP, tracking the mouse position and syncing the visuals in real time. All right, now that we've set up our references, it's time to actually build the visual part of our custom cursor right inside the return statement. So let's start by creating the main dot that represents the core of our custom cursor. We're going to add a div for this dot and attach the cursor ref we created earlier to it. This ref will allow us to animate it later using GSAP. Next, we need to style this dot so it looks clean and modern. First, we apply fixed, which ensures the dot stays in a constant position. Then we use top 0 and left 0 to initially position it at the top left corner. For size, we go with a width and height of 20 pixels each, which makes it subtle but still visible. The BG white gives it a bright white color, and rounded full makes it a perfect circle. Next, we add pointer events none. This is super important because it tells the browser to ignore this element when it comes to clicking or hovering, so it won't block buttons or links underneath. We also give it a high Z index using Z99 so that it stays on top of all other content on the page. Finally, we apply mix blend difference. This is a really cool trick that inverts the color of whatever is behind the cursor dot, making it look awesome whether it's over light or dark backgrounds. And that's it. Now that we have our main cursor dot in place, let's complete the custom cursor by adding the outer ring. Right below the dot's div, we're going to create another div slash. First, we attach the ref cursor border ref to this div. Just like the dot, this reference allows us to animate and control it later using GSAP. Then we style it with Tailwind to get the perfect visual. We start again with fixed top 0 and left 0 to keep the ring locked to the screen and aligned from the top left initially. For the size, we give it a width and height of 40px each. Double the size of the dot so the ring clearly wraps around it. Instead of using a solid background color, we use border and specifically border white, which gives us a white ring instead of a filled circle. To make it circular, we use rounded full, and once again, we add pointer events none so that it doesn't block any interaction on the page. We also give it a high Z index using Z999 to make sure it stays on top of everything, just like the dot. Then we apply mix blend difference so the ring blends nicely with both light and dark backgrounds. Finally, we tone it down a little by adding opacity 50, which gives the ring a semi-transparent appearance. This softens the effect and makes sure it doesn't distract from the actual content on the page. All right, so now we want our custom cursor to disappear when someone views our website on a mobile or tablet device. This is really important because mobile users don't use a mouse, so having a cursor doesn't make any sense and can even feel broken or out of place. To handle this, we're going to add a quick check at the very top of our component's return logic. The idea here is to detect if the user is on a small screen, like a phone or a tablet, and if so, just completely stop rendering the cursor component. To handle that, first, we create a condition to check if we're running in the browser. So the very first thing we say is if the window object exists, we're good to go. Then we use something called match media, which is like writing a media query, but in JavaScript. We pass in a condition that says, is the screen width 768 pixels or less? That's basically anything from a smartphone up to a smaller tablet. If this condition is true, we know the user is on a mobile device. And finally, if the screen is too small, meaning the user is on mobile, we return null. That means don't render anything at all from this component. Shrink your browser window down to mobile size and refresh the page. The cursor disappears. Widen the screen again, refresh, and just like magic, it's back. Now it's time to implement the core logic for animating our custom cursor. To achieve this, we'll use React's useEffect hook. This hook runs when the component mounts, kind of like saying, hey, browser, once this component is added to the page, do this setup work for me. So the first thing we do here is grab the actual DOM elements of the cursor and its border using React refs. We've already defined those earlier with useRef, and now we're accessing the current elements they point to, one for the center dot and one for the ring around it. We're now at the part where we want to bring it to life using GSAP. So the first thing we need to do is get GSAP into our project. Let's head over to the terminal. Before installing anything new, we need to stop the React development server. Just press Ctrl+C on your keyboard. Now let's install GSAP by typing the command npm install GSAP. Hit enter and give it a few seconds. Once the installation is done, we can bring our app back to life by running the command npm run dev. Next, let's head into the file. At the very top of the file, we need to import GSAP so we can use its animation functions. So we'll write an import statement that brings in GSAP from the GSAP library. Now with GSAP available, we're ready to set up the animation. Let's scroll down to our useEffect hook. This is where we're going to set the initial position of the cursor elements. By default, when the mouse moves, we want both the cursor dot and the ring to be perfectly centered on the actual cursor position. So we use gsap.set, which is basically a way to instantly apply a style to elements before any animation starts. And here we pass in both our cursor dot and the ring. We want to set both at the same time. What we're doing is shifting their position by 50% on both the X and Y axis. Now it's time to setting up the variables that will control the position of our cursor. But here's the cool part. We're giving them different speeds using GSAP. This is what creates that beautiful trailing effect between the dot and the ring. We start by defining a variable for the X position of the dot. That's the small center circle. We use gsap.quick2 here. This method is super efficient. Instead of creating a brand new animation every time the mouse moves, it creates a fast, reusable updater. This keeps our app smooth and performant even when animations are happening constantly. So this first variable moves the dot along the x-axis. We give it a duration of 0.2 seconds, so it reacts quickly to mouse movement. For the easing, we use power3.out. This gives us a nice, smooth slowdown toward the end of the motion, making it feel responsive but not stiff. Next, we do the same thing for the Y position of the dot, again with the same speed and easing, because we want the dot to move in sync in both directions. Now, here comes the magic. We define a separate set of variables for the ring. That's the larger circle around the dot, but this time we slow the movement down. Instead of 0.2 seconds, we set the duration to 0.5 seconds. This makes the ring lag just a bit behind the dot, creating that satisfying modern trailing effect. So again, one variable for the X position of the ring and one for the Y. For easing, we're using slightly different values to add more character. One uses power.out and the other power3.out. Both of these are easing functions provided by GSAP that give our animations a smooth, professional feel. What we've done here is separate the speed and feel of the center dot and the outer ring. But when I save the file, the app breaks. This kind of thing happens all the time when you're coding, even as a pro developer. Most of the time, it's just a small typo or a minor mistake, and the fix is usually quick once we find it. So, to debug this, let's head over to the browser where our app is running. Right-click anywhere on the page, then from the menu that pops up, let's click Inspect. This opens up the Developer Tools. Now, from the top of the panel, click on the Console tab. This is where JavaScript will report any errors it's seeing in our code. There's a red error message coming from our customcursor.jsx file. Let's open it up to see what's going wrong. The error message is pointing us to our useEffect hook, saying it's not working the way it should. Now let's scroll up and check the import statement. And there it is. I made a small typo. I accidentally typed useEffects instead of useEffect. And as soon as we save, the error disappears and the app works again. All right, now that we've defined the logic for how our custom cursor should animate, with different speeds for the inner dot and the outer ring, it's time to actually bring that cursor to life. And to do that, we need to hook it up to real mouse movement on the screen. So let's start by creating what's called a mouse move handler. This is basically a function that runs every time the mouse moves. Inside this function, we'll tell our cursor elements exactly where to go based on the mouse's current position. We begin by defining the function and giving it access to the event object. That's the E you see there. Now here's the cool part. Inside the function, we use those position values, e.clientx and e.clienty, to update the cursor's location. They're powered by GSAP and are ready to smoothly animate our elements. So here we simply pass the mouse's current X and Y positions into them. We do the same for the outer ring, the cursor border, using the xToe border and yToe border functions. Once that handler function is set up, the final step is to make sure the browser actually runs it whenever the mouse moves. And that's where we add a mouse move listener. We do this by telling the browser, hey, every time the mouse moves, run this handler function. So we attach our function to the mouse move event on the window itself. This way it works anywhere on the page. I made another typo, this time in the handle mouse move variable. Make sure it's written in proper camel case format to avoid any issues. And that's it. With this logic in place, our custom cursor is now following the mouse in real time with smooth animations and responsive feedback. All right, now let's finish up our custom cursor by adding just one more touch that really makes it feel interactive, and that's a click animation. So far, we've built a cursor that smoothly follows the user's mouse movements, but when we add a click effect, it gives a really satisfying response and makes the interface feel much more polished. Here's how we'll do it. We're going to listen for two types of mouse events, when the mouse is pressed down and when it's released. We start by telling the browser, hey, when the user clicks anywhere on the page, and for that we use the mouse down event, we want to shrink the cursor a bit. Inside the event listener, we use GSAP's to method to animate both the dot and the border by scaling them down. We set the scale to around 0.6 and give it a short duration, like 0.2 seconds, so it feels quick and snappy. Then we do the opposite for the mouse up event, which is when the user lets go of the click. This time, we tell GSAP to scale both cursor elements back to their original size, scale of 1, again with a short duration, so the cursor smoothly bounces back. And that's all we need. Upon clicking, the scale down animation is triggered as expected, but the element doesn't revert to its original size. This behavior is due to a typo I introduced in the code. After correcting it, the animation now performs as intended, scaling back smoothly to its default state. There's just one last step to polish things off. You may have noticed that even though our custom cursor is working, the default browser cursor is still showing up underneath it. We want our custom cursor to be the only one the user sees. So to remove the default one, we're going to head over to our index.css file. We target the body element and simply tell it, don't show the regular cursor. This is done by setting the CSS cursor property to none. Once we do that and save the file, the browser's built-in cursor disappears completely, leaving just our custom cursor on screen. Let's continue building out the next sections of our project. I've already prepared all the assets we need, and you can find them in the GitHub repo. The link is right down below in the description of this video. While you're there, feel free to give the repo a star to support the project. It really helps. Now let's start by setting up our styles. Open the index.css file in your project. This file includes some base styles that are shared across different sections. These are just simple resets and utility enhancements to make sure our layout behaves consistently across all browsers. Don't worry, we'll still style every part of our website from scratch, and I'll walk you through every single line as we go. For now, go to the GitHub repo, copy everything inside the index.css file, then go to your own index.css, delete everything that's there, and paste in the code we just copied. That sets the foundation. Next, open the tailwind.config.js file. This file is where we customize Tailwind to match our design, things like adding custom colors, extending spacing, or enabling specific variants. Again, head to the GitHub repo, copy the code from the tailwind.config.js, and replace your own with it. This will make sure Tailwind is set up exactly how we need it for this project. Now let's set up our images. You'll need 4 images to showcase your projects and 1 personal image. This could be your profile photo or a cool graphic that represents you. You're totally free to use your own images, but if you want to follow along exactly, you can grab the same ones I'm using from the GitHub repo. To add the images to your project, first go to the public folder in your React project. Inside there, create a new folder and name it Images. Then just drag and drop your images into that folder. Done. That's all we need to get started with our visuals. Awesome. Now that we have all our base styles, config, and assets in place, we're ready to dive into building out the actual layout and components. Now let's move on to the About section. We're going to keep things super organized by creating this as a separate component. So, inside the Components folder, let's create a brand new file and name it aboutsection.jsx. Once that file is created, the first thing we'll do is type out a shortcut that stands for React Arrow Function Component Export. If you're using the ES7 Plus Snippets extension, this will automatically generate a functional component for you. Since we're using the latest versions of React, where importing React explicitly is no longer needed, we can go ahead and delete that line. All right, now that our component is set up, let's connect it to our main app. Open up your app.jsx file and import the new About section component, just like we do with any other component. Then find the spot right below your custom cursor component in the return statement and add our About section there. That's it. We've successfully plugged in our new section. Now let's head back into aboutsection.jsx. We'll start building out the actual content. First things first, let's clean things up a bit. We'll remove that default div element and replace it with a proper section tag. This makes more semantic sense since this is a full section of our page dedicated to the About Me content. Now for the styling of this section, we'll add a class name with Tailwind CSS utility classes. We want this section to take up the full height of the screen, so we use hscreen. We also want to set it up for layered content, so we give it relative. We don't want anything to accidentally overflow, so we apply overflow hidden. Then, to create a smooth background effect, we use a gradient from top to bottom, starting with pure black and blending into a soft, semi-transparent purple, using BG gradient dash to B from black. This gives us a really nice, soft background with some depth. Next, let's add the title for this section. We'll do that by creating a div. This will serve as the container for the heading. Then inside that, we place an h1 element with the text About Me. Now let's style the heading. We want it to be big and bold, so we use text 4XL for mobile and MD text 6XL for medium screens and up. Then we add font bold to make the text stand out, and SMMB16 to add space beneath it on small screens and up. We center the text with text center, and finally we make it white using text white. As for the container div that holds this heading, we want it perfectly centered both vertically and horizontally. So we use container for responsive padding, MX auto to center it horizontally, and PX4 for a bit of side padding. To center everything vertically, we make it take up full height with hfull, then use flex, and align it using flex call, items center, and justify center. Awesome. Now before we move on to adding more content inside our About section, Let's take a moment to bring it to life with a simple GSAP animation. This will add a smooth entrance effect to our title, making the user experience feel way more dynamic and modern. So first, we need to prepare our React component to handle animations. For that, we'll import two essential React hooks, useRef and useEffect. useRef is used to grab a direct reference to an element in our JSX, and useEffect will help us trigger the animation once the component is mounted. Once those are imported, we go ahead and assign a reference to our H1 element, the one that says About Me. Let's call it TitleRef. This allows us to directly target this element with GSAP. Next, we import GSAP itself. At the top of the file, we bring it in by writing import GSAP from GSAP. We also want to animate the whole section if needed, so we give our main section, tag a reference as well, and name it sectionRef. Then right above our return statement, we declare both refs by writing const sectionRef equals useRef null and const TitleRef equals useRef null. This sets up two constant variables that point to those elements. Perfect. Let's keep going and add the scroll animation to our title using GSAP. So first, let's set the opacity of the H1 element to 0. This means it will be completely invisible when the page first loads, and then GSAP will animate it into view. Now let's define the actual animation. Just above the return statement in our component. This is where we're going to use the useEffect hook to define what should happen when the component mounts. Inside that useEffect, we'll call GSAP's FromTo method. What this does is animate an element from a certain state to another state. We target our title by accessing titleref.current. We tell GSAP to start at 100 pixels lower with an opacity of 0, so it's hidden and pushed down. Then we animate it to move upward to minus 300 pixels on the y-axis and fade in to full opacity. We set the duration to 0.8 seconds, which gives it a quick but smooth entrance. Now, to make this animation trigger only when the About section scrolls into view, we'll need to use GSAP's Scroll Trigger plugin. But before we can use it, we need to import it. So head back up to the very top of your component, and just below the GSAP import, we write import scroll trigger from GSAP/scroll triggers. This allows us to hook the animation into the scroll behavior. Great, now let's finish setting up the scroll animation for our title by adding the scroll trigger logic inside the useEffect. So right at the start of the useEffect, the first thing we want to do is register the scroll trigger plugin with GSAP. This is super important because GSAP doesn't automatically know we're using that plugin. We have to explicitly tell it. Once that's done, we can use all the scroll triggered animation features that come with it. Now let's go down to our FromTo animation for the title element and define the scroll trigger object. This is what controls when the animation actually happens based on the user's scroll position. Inside the scroll trigger, the first property we define is trigger, and we set it to sectionRef.current. That means the animation will begin when this whole section, the About section, reaches a certain position in the viewport. Next, we define the start position. This tells GSAP when to trigger the animation relative to the viewport. So we write top 40%, which means the animation starts when the top of the About section hits 40% of the way down the screen. This gives us a natural-looking timing where the title animates in just as the section comes into focus. Finally, we define toggle actions. This is a string with 4 actions that control how the animation behaves when the user scrolls in and out of the trigger zone. We set it to play, none, none, reverse. That means the animation will play when scrolling in, it won't do anything when leaving or re-entering, and it will reverse if the user scrolls back up. And that's it. Great. Let's continue building out the rest of our About section by adding more content and styling everything step by step. So right below the titles container div, we're going to create another div. This new div will act as a container for the next elements, our introduction text and personal image. Inside this new div, we start by adding an H3 element. This is a subheading where you can write a short, friendly intro about yourself. Now, let's style this H3 element. We use TextSem for small screens and scale it up with MD Text 2XL for medium screens and larger. Then we make it bold with font bold and give it a soft purple color using text purple-200. To make sure it sits above other elements, we apply Z50. We also want to limit the width so the text doesn't stretch too far, so we use LG Max W5 rem and Max W27 rem for smaller screens. Then to add spacing and breathing room, we apply some vertical positioning using tracking wider for more letter spacing. And for the margin top, we use responsive values, MDMT20, SMMT-40 rem, and MT-32 rem. These help position the text depending on screen size. Next, just below the H3, we add an image element that will display your personal photo. You can link this image to a file you've placed inside your public/images folder earlier. For styling, we give the image a responsive height using Tailwind classes like LGH40rem, MDH25rem, and 8 for smaller screens. We also apply Mix Blend Lighten to blend the image nicely into the background, giving it a soft, almost glowing look depending on the background colors. Now, at this point, you might notice there's an extra scroll bar showing up. This isn't something we want, and it's happening because we accidentally set the overflow of the main section element to auto. But before that, we should also make sure that the container div wrapping our intro text and image is styled properly. We give it absolute, and for vertical placement, we use LD bottom -20 rem, MD bottom 10 rem, and bottom-20 rem for different screen sizes. It's positioned to the left with left 0 and stretched full width using W full. We set it up as a flex container so we can easily control the layout using flex, MD flex row for side-by-side layout on medium screens and up, and flex col for stacking on smaller screens. Then we use justify between to space out the items and padding with LG PX24 and PX5. We center the items vertically with item center. And finally, we apply opacity 0 to make it invisible initially. This will come in handy later when we animate it into view with GSAP. Great. Now that we've added the introduction text and the image to our About section, let's bring them to life with a GSAP scroll animation, just like we did for the title. First, we need to prepare the container div that wraps both the intro text and the image. Now let's make this element targetable by GSAP. To do that, we assign a ref to the div. We simply write ref equals intro ref on that container. This gives us direct access to that element from within our code. Then let's scroll up to the top of the component where we've declared our other constants. Just below the existing section ref and title ref, we add one more. Const intro ref equals use ref null. This sets up the reference so GSAP can interact with the element. Next, we go inside our use effect, just under the block where we define the title animation. Now it's time to define the animation for the intro container. We use gsap.fromTo again, and we target introref.current. We set it to animate from Y100, opacity 0, and a heavy blur with filter blur 10px. That makes it start off lower on the page, fully transparent and slightly out of focus. Then we animate it to Y-400, opacity 1, and remove the blur by setting filter blur 0px. This makes it rise up, become sharp and visible, and creates a beautiful transition effect. We give it a smooth duration of 1.5 seconds so the animation feels soft and elegant. Of course, just like before, we define the scroll trigger object to tell GSAP when to run this animation. We set the trigger to our About section using sectionref.current and the start to top 40 cent, which means the animation kicks in when the section reaches 40% of the viewport. We also use toggle actions play none, none reverse, so it plays on scroll and reverses when scrolling back up. Now, a quick but important note, make sure the Y value is lowercase. Otherwise, the animation simply won't work. GSAP is case sensitive. And finally, let's scroll down and fix one small thing we talked about earlier. The overflow on our main section element was set to auto by mistake, which is what caused the unnecessary scroll bar. So we just changed that value from auto to hidden. That will clean things up visually and prevent any extra scroll behavior. All right, let's move on and build the final visual touch for our About section. Floating stars that gently move around as the user scrolls. So here's how we set it up. We start inside the main section element, and right above the title element, we create a new div. This div will serve as a container that holds all of our star elements. We give it a class name and apply a few key Tailwind styles. Absolute makes sure it's positioned relative to the section and layered exactly where we want. Inset 0 stretches it to cover the entire area of the section, from top to bottom and left to right. Overflow hidden keeps anything from spilling outside the section, which is important for keeping the stars neatly contained. Now let's talk about how we actually generate the stars, and I'll explain this part line by line. We use a bit of JavaScript magic here with an array, array10.map. Here's what's happening. Array10 creates a new array with 10 empty slots, spreads that array so we can map over it. .map I loops through each item. Score is the unused item itself, and I is the index, which we'll use to size and key each star. Now, inside the map, we return a div for each star. Key equals star I gives each star a unique key like star 0, star 1, and so on. This is important in React for performance and to avoid warnings. Class name absolute rounded full positions each star absolutely inside the container and gives it a circular shape using rounded full. Then comes the style object, where we define the look and position of each star. Width and height are set to a base size of 10 pixels, and then we increase it a little more for each star. This creates stars of different sizes, which adds visual variety. Background color, white, gives them a glowing white look. Opacity is randomized between 0.2 and 0.6 by using 0.2 plus math.randoms 0.4. So some stars are dimmer and some shine a bit more. Top and left are set using math.random 100, which gives each star a random position anywhere within the section. 100% means it could be placed anywhere from top to bottom and left to right. And that's it. With this one smart snippet, we've created 10 floating stars of different sizes, brightness levels, and positions. In the next step, we'll animate these using GSAP to make them drift or pulse, so they feel like they're gently moving as the user scrolls. First, scroll to the top of your component file. Right below the other constant variables we've already defined, let's create a new constant and call it starsRef. We're going to set it using the useRef hook, and we'll initialize it as an empty array. This ref will hold direct references to each star element in our layout, so we can animate them individually with GSAP. Once that's set up, scroll down to your useEffect hook. We've already got the intro animation inside it, and now we're going to add a new block right below that to handle our stars animation. Here's what's happening in this block. We're looping over each item in starsRef.current, which holds our star elements. For every star, we determine a direction based on its index. If the index is even, the direction will be positive. If it's odd, it'll be negative. This gives our stars some variety in their movement. They won't all drift in the same way. Then we set a speed for each star using a bit of randomness. That makes each one scroll at a slightly different pace, again to create a more natural and dynamic feel. Now comes the GSAP part. We're using GSAP to animate each star. We're moving them both horizontally and vertically using the X and Y properties. And we're also rotating them as they scroll. These values depend on their direction and index, so no two stars move exactly the same. And then finally, we're attaching a scroll trigger to each animation. This means the movement is tied to the user's scroll. We set it so that the animation starts when the section comes into view and ends when the section scrolls out. The scrub value is where the speed comes into play. It smooths out the animation based on how fast the user is scrolling. Inside the use effect, we still need a cleanup, so we add a return function. Think of this return as React's way of saying, do a little housekeeping when the component unmounts or when its dependencies change. Here's what happens in plain words. Grab every active GSAP scroll trigger. We ask scroll trigger for its full list so we can inspect each one. Look at each trigger in that list. Oh, for the scroll trigger here, make sure it starts with a capital S. It's case sensitive and won't work otherwise. Now, for every trigger, we check what element it's attached to. Keep only the triggers that do not belong to our section. If the trigger's trigger property matches the exact element held in section ref, it means that trigger belongs to this section. We don't want it hanging around after the section disappears, so kill those matching triggers. Calling kill cancels the animation and removes the event listeners, freeing memory and avoiding awkward leftover scroll effects once we navigate away or re-render. Great, now let's complete the stars animation. To start, head over to the main div that contains all our stars and assign it a ref called add to stars. This ref will help us keep track of each star element as it gets rendered. Next, right above the main return statement in your component, but outside the useEffect hook, create a new constant named add to stars. This will be a function that receives an element as a parameter. Inside this function, we first check if the element exists, and then make sure it hasn't already been added to our stars ref array. If both conditions are true, we push that element into the starsRef.current array. This allows us to collect all the star elements dynamically and use them in our animations. Now, when you preview your project, you'll see the stars smoothly flowing around the screen as you scroll through the section. This effect becomes even more impressive once we add the other parts of the project, so keep following along. Next, we build the projects section. Head into the components folder and create a new file called projectsection.jsx. Generate a React arrow function component with the raf snippet, then delete the automatic import React line. It isn't needed in modern React. Inside the component, swap the placeholder div for a section element. Give this section an ID of horizontal section. Later, we'll use that ID to target the section for horizontal scroll logic. Now add Tailwind classes to style the section. Set it to relative so absolutely positioned children can anchor to it. Add generous vertical padding with pi20 so the content has room to breathe. Set the background to white to make the project cards stand out. Finally, add overflow hidden so anything that slides outside the viewport isn't visible while we animate horizontally. Because we'll need to measure and control the element in JavaScript, import useRef and useEffect from React. Attach a ref called sectionRef to the section element so React can hand us the DOM node. Just above the return statement, declare sectionRef with useRef null. That initial null tells React there's no node yet. Once the section mounts, React will assign the actual element to sectionRef.current. Now, right inside the section element, the first thing we want to add is the title. We wrap it in a div so we can center and space everything neatly. By giving that div the class's container and mxauto, we lock its maximum width and keep it perfectly centered. The px4 adds gentle side padding, mb16 drops a healthy margin below, relative lets us layer absolute items later if we need, and z10 ensures the title always floats above other content. Inside that wrapper, we drop an h2 tag that reads featured projects. The headings class list does a lot of heavy lifting. Text 4XL sets a large base size, then MD Text 5XL and LG Text 6XL let it scale up gracefully on tablets and desktops. Font bold makes the words pop. Text black keeps the color crisp against the white background. Text center centers the line, and MB4 adds a touch of space below. I'd almost forgotten to register this new component in app.jsx. A quick import at the top and a single function call right under the About section drops it into the page flow. Now our projects component is live. In the next step, we are going to add a colorful gradient line right below the title that animates as the user enters this section. So inside the same container div that holds our heading just beneath the h2 element, let's create a new div. This will visually act as our animated underline. We'll style it with Tailwind classes starting with W0 to make its width 0 at first, because we'll animate it later with GSAP. Then H1 gives it a slim, clean height like a divider. For the background, we use a gradient that flows from purple to pink, so we apply BG gradient to R from purple 500 to pink 500. That gives it a nice techie glow. And finally, MX Auto horizontally centers the line so it sits right beneath the heading, no matter the screen size. Now, we'll also add opacity 0, so it's hidden when the user first lands on the page. This way we can animate both its appearance and its width smoothly. Since we'll animate this element later, we'll attach a React ref to it so GSAP can target it directly. We'll name the ref title line ref in camel case, which keeps things readable and consistent. And while we're here, we'll also set the opacity of the H2 element to 0 for the same reason, so we can fade it in along with the animated line when this section becomes visible. Give the heading its own ref as well, named title ref. Then, right above the return block of our component, let's declare both of these references using React's useRef hook. So we'll create two constants, titleRef and titleLineRef, each initialized to useRef null. This setup is now ready for us to trigger a smooth entrance animation using GSAP in the next step. We've structured everything carefully. Inside our project's component, we want the heading and its gradient line to fade and grow the moment the section scrolls into view. To make that happen, we drop into the useEffect hook that sits right below the constants we just declared. At the very top of the file, we first bring in GSAP's core, GSAP, and its scroll trigger helper so that GSAP can listen for scroll events. Within the effect, the first line registers scroll trigger with GSAP, letting the animation library know we'll be using scroll-based cues. Right below the setup, we define the animation for our title. We use GSAP's FromTo method, which lets us specify the starting and ending states of the animation. We target the title element by accessing its current reference. Initially, the title starts 100 pixels down from its final position and is completely transparent. Then, over a little more than 1 second, it moves smoothly up to its natural position and fades in to full opacity. We add an easing function called power3.out to make the movement feel natural and smooth. To tie this animation to the user's scroll, we use scroll trigger. The trigger is set to the entire section containing the title, and the animation begins when the top of that section reaches 80% down the viewport. The toggle actions tell the animation to play when scrolling down and reverse when scrolling back up, but it won't restart repeatedly during the scroll, keeping the experience clean and polished. Now you can see the animation has been successfully applied to our title. It's looking great. Next, we'll move on to animating the title line. So just below the title animation, still within the same useEffect hook, we'll define the title line animation like this. Using GSAP's FromTo method again, we target the line element through its reference. At the start, the line's width is 0%, so it's invisible, and its opacity is set to 0, making it fully transparent. Then, over a duration of 1.5 seconds, it smoothly expands to full width, becoming completely visible as the opacity changes to 1. The easing function power3.inout gives the animation a smooth and natural flow in both directions. We add a slight delay of about 0.3 of a second, so the line starts animating just after the title begins to appear. Just like with the title, we use scroll trigger to tie this animation to scrolling, with the same trigger and start position and the same toggle actions, so the animation plays when entering the section and reverses when scrolling back up. This creates a smooth and polished reveal for both the title and its underline as the user scrolls down. Great, now let's add the other elements of our project section. So scroll down right below the section title, and here we're going to build the horizontal scroll area. Let's start by creating a wrapping div that will contain everything inside this scrollable section. Give it a class name and set its overflow to hidden. This will make sure that anything outside the bounds of this section will be clipped. Now, inside this wrapper, we're going to create another nested div. This one will be the actual track that scrolls sideways. Give it a class name and apply the following Tailwind styles. Make it a flex container so all items line up horizontally, and set its width to 400% on medium screens and 420% on smaller devices. This gives enough room to fit several project cards side by side and scroll through them smoothly. Next, let's handle the data for each card. Instead of manually creating each one inside the JSX, we'll use a list to manage this more efficiently. So, scroll back up to the top of the component, and here we'll create an array of objects that each represent a project. Let's name the array Project Images. Each object in this list should include an ID, a title, for example, 3D gaming website, and a relative path to an image. These images can be the ones we downloaded from the GitHub repo and placed in the public/images folder. You can completely customize this with your own projects and details, depending on what you want to display in your portfolio. Now, instead of typing out every project manually, just copy the first object and paste it below to create the rest, updating the info like the title, image path, and IDs as needed. Once your array is ready, scroll back down to the return statement. Inside the horizontal scroll container we built, we're going to map through that array and render a card for each project using the data from our list. We switch back into JavaScript by opening a curly brace, then call map on the project images array. React loops through every project object, handing the current object into the arrow function parameter called project. It seems like there's an issue with the image path, most likely a naming mismatch. Let's scroll up and take a look. And yes, we've typed image instead of images. Let's correct that, and that should resolve it. For each project, we return a top-level div. React needs a unique key, so we pass project.id. Tailwind classes follow. The custom panel class, defined in index.css, forces this element to fill the viewport, width 100% and height 100 VH, so each project occupies an entire screen as you scroll horizontally. Relative establishes the element as the positioning context for anything nested and absolutely positioned later. Flex turns the box into a flex container, and item center justify center aligns anything inside perfectly in the middle, both vertically and horizontally. The extra loading word is just an attribute placeholder. Here it has no effect, but could be hooked to lazy loading logic later. Nested inside that is another div, which actually holds the card's content. This inner wrapper is also relative, giving us another positioning context if we decide to overlay labels or icons. The classes wFull hFull force it to stretch to the full width and height of its parent. Then we declare it as a column-oriented flexbox with flex call. Again, we center content with items-center justify center. Finally, we add responsive padding. Small devices get a modest P4, medium screens bump to P8, and large screens expand to P12, so text and images never feel cramped. Inside this content wrapper, you drop an IMG element. The image's sarc would come from project.image, showing the project preview, while alt helps accessibility. Add Tailwind utilities so the preview always fills its box. Give this element the custom class project image. Later, when we wire up GSAP, that selector makes it easy to target every image for motion effects. Max wFull, max hFull keeps it from scaling past the container. Rounded turns the thumbnail into a circle, and object cover keeps the aspect ratio while cropping the edges if needed. That combo guarantees a crisp, centered avatar-style preview at any screen size. Right beneath the image comes an H2 tag that shows the project's title. Because we also want a little link icon next to the name, first import the icon component from React Icons at the top of the file, then place that icon inline before or after the text, whichever looks better in your design. Give the heading the custom class project title. Then layer on Tailwind Utilities. Flex Items Center Gap 3 aligns the text and icon neatly with a small gap. Responsive type scales with MD Text 3XL while mobile stays at text sem. To make it stand out, add MD font bold and text black, followed by MT6 for spacing below the image. The Z50 keeps the heading above any background elements inside the panel. For a subtle interactive cue, add hover text gray 400, transition colors duration 300 cursor pointer. The title now dims slightly on hover and shows the user it's clickable. With the card complete, it's time to prepare the horizontal scroll logic. First, attach a ref to the long div that holds all project panels. Call it horizontal ref. Also attach another ref named trigger ref to the main wrapper around that track and set this wrapper's opacity to 0. We'll fade it in when the scroll animation kicks off. Just below your other constant declarations, create const trigger ref equals use ref null and const horizontal ref equals use ref null so React can store those DOM nodes. So let's define the animation for our horizontal scroll container using GSAP. Right inside our useEffect hook, just after setting up the title and title line animations, we're going to create another GSAP animation that fades in and animates the main container of our project cards. We start with gsap.fromTo, which takes two arguments, the initial state and the end state of the animation. For the target, we use triggerref.current, which is the outermost wrapper of the horizontal scroll section. In the first object, we define the starting properties. We move the element down slightly with Y set to 100, giving it a nice rising effect when it appears. We add a rotation X of 20 degrees to tilt it forward just a bit, and we set the opacity to 0 so it starts off completely hidden. Then in the second object, we define the final state. We bring Y back to 0, we reset the rotation X to 0 so it straightens out, and we set opacity to 1 so it becomes fully visible. We set the animation to last for 1 second and use the power2.out easing for a smooth deceleration effect. A small delay of 0.2 seconds makes sure it doesn't fire too soon, allowing the title and line animations to complete first. Finally, we hook it all into scroll behavior with scroll trigger. We set the trigger to be sectionref.current, which means the animation will be activated when this section enters the viewport. The start value is set to top 70 cent, which means the animation begins when the top of our section hits 70% from the top of the viewport. For toggle actions, we use play none none reverse, so the animation plays as we scroll into view and reverses when we scroll back out. This brings our horizontal scroll container smoothly into view with a subtle lift and rotation, helping the section feel dynamic and polished as part of our modern scroll experience. All right, let's check it out to see how this section is looking so far. Looks like there's an issue with our title line animation. First off, we need to update toggle action to toggle actions. That's a common mistake. Now let's dig into what's going wrong with the title line animation. There it is again. The same typo. We'll correct toggle action to toggle actions once more. Also, I accidentally added an extra R in the word trigger, so let's fix that as well. Honestly, the more time you spend coding, the easier it is to make little mistakes like these. So if you run into errors too, don't worry, it's totally normal. Oh, and here's one more typo. The ref name for our horizontal line isn't correct. Let's quickly fix that too. And there we go. Everything's working now. Let's move on and define the rest of the logic. Head back into the use effect hook, and just below the section entrance animation, we're going to set up the parallax effect for the entire section. For the parallax backdrop, we reach for GSAP.FromTo. We point it at sectionRef.current, the entire project section. In the from object, we set background position to 50% 0 cent, centered horizontally aligned to the very top. In the to object, we move that position to 50% 100%, sliding the background image straight down over the course of the scroll. The easing is none, so the shift is perfectly linear. Then we wire in scroll trigger. Its trigger is the same section, meaning the effect only runs while this section is on screen. Start top bottom begins as soon as the section's top edge touches the bottom of the viewport. End bottom top finishes when the section's bottom edge reaches the top of the viewport. Setting scrub true. True ties the animation's progress directly to the scroll position, giving that classic parallax glide, background drifting steadily while the content scrolls. Now, right below that parallax setup, we create the core horizontal scroll animation. We tell GSAP to target every element with the class panel, that's each full screen project card, then shift them sideways as the user scrolls. The amount of movement is set with X%. We multiply -100 by 1 less than the number of project images, so the track slides left one full viewport for every additional panel, ensuring each card stops neatly in the center of the screen. We keep ease set to none, so the slide is perfectly linear, no unexpected acceleration or deceleration. Next comes the scroll trigger configuration that ties everything to real scrolling. The trigger is triggerRef.current, our wrapper that surrounds the horizontal gallery. The animation starts the instant that wrapper's top meets the top of the viewport and ends only after the track has traveled its full width. Pleichel's offset width lets GSAP measure that distance on the fly. Pin true freezes the section in place while the track glides, creating the sense of a sideways film strip. Scrub 1 links the animation time directly to scroll position with a small 1-second smoothing buffer so the motion feels fluid. Snap ensures each panel settles cleanly. We tell scroll trigger to snap in equal fractions, 1 divided by the number of gaps between panels. A short main duration and delay mean the snap is gentle, not jarring. Finally, invalidate on refresh true forces GSAP to recalculate widths on resize so the gallery stays perfect on every screen. Nice. Now, finally, we are going to define the animation of our images inside each project panel. And for this, we're going to loop through each of them and animate both the image and the title as they slide into view. Let's walk through everything clearly and slowly. We start by grabbing all the panels on the page using gsap.utils.toArray. This converts every element with the class panel into an array we can loop through. Remember, each panel is one full screen card in our horizontal scroll section. Next, we run a for each loop over those panels. For every panel in the array, we're pulling out two things. First, the actual image we want to animate, which has the class project image, and second, the title, which uses the class project title. Now for the animation part. This is where it gets interesting. For each panel, we create a unique GSAP timeline. This timeline is tied to a scroll trigger, just like our other animations. But what makes this one different is that we're using the horizontal scroll we already created as the container animation. That means instead of listening to the native page scroll, it listens to the horizontal movement we've built earlier. The trigger is set to the current panel. The animation begins when the left edge of the panel reaches the right edge of the screen, so just before it fully enters, and ends when the right side of the panel leaves the left side of the screen. The scrub, true setting, makes sure the animation stays in sync with the scroll progress, meaning if you scroll forward or backward, the animation plays in both directions. Inside this timeline, the first animation targets the image. We animate it from scale 0 to scale 1, making it appear to grow from nothing. At the same time, we rotate it from -20 degrees to just 1 degree, adding a touch of natural motion and style. The animation runs over half a second, making the entry smooth and lively. Right after that, we check if the panel has a title. If it does, we create another animation for the title element. We animate the Y position of the title from 30 pixels downward to -100 pixels upward, making it move upward as the panel scrolls. We also add a slight delay of 0.2 seconds so that the title comes in just after the image has appeared. This creates a clean layered effect where the image enters first and then the title follows. And that's it. This approach gives each project card its own set of scroll-triggered animations, fully coordinated with the horizontal movement. Next, we need to add a dependency array to the useEffect hook. Specifically, we'll include projectimages.length. This is crucial because both the horizontal scroll logic and the image animations rely on the number of project cards, or dot panels, present in the DOM. If a project is added or removed, the value of projectimages.length changes, which triggers the useEffect to rerun, ensuring that all scroll-based animations are accurately recalculated and stay in sync with the current layout. Looks like I made a small typo again, apologies for that. This time, it's in the horizontal scrolling animation logic. When referencing the panel class, we need to make sure to include the dot prefix. So instead of just panel, it should be dot panel. Fixing snap to snap to corrects the scroll trigger snapping option, letting the gallery ease neatly to each card instead of stalling in between. Even after those tweaks, the sideways scroll still feels off because scroll trigger needs to be set up once for the whole application. So we switch to app.jsx and import 3 tools at the top. UseEffect gives us a lifecycle hook. GSAP is the animation engine. And Scroll Trigger is the plugin that syncs GSAP with scrolling. Inside the app component, right above the main return, we add a useEffect with an empty dependency array so it runs only once when the app mounts. The first line registers scroll trigger with GSAP, telling GSAP to make all the scroll trigger features available. Next, we call refresh. This forces scroll trigger to measure every pin, start, and end point after the entire page finishes loading, which is essential when elements have dynamic sizes. Finally, we provide a cleanup function. React calls it when the component unmounts or the page hot reloads. Inside, we loop over every active scroll trigger and kill it. That prevents memory leaks and stale scroll listeners during development. With registration, refresh, and cleanup in place, the project section's horizontal gallery now snaps, pins, and scrubs exactly as intended, smooth, accurate, and error-free. Amazing, time to build the contact section. Think of this as adding the final chapter to our page. First, inside src, create a new file and name it contactsection.jsx. In that blank file, type the shorthand. Your snippet tool instantly expands it into a React arrow function component and default export. We don't need the auto-generated import React from React line, so delete it to keep things tidy. Next, register this new section in app.jsx. At the very top of the file, add an import that points to the component you just made. Then scroll down the JSX tree and drop contact section right below the projects section. Save. Now the contact component is part of the page flow. Head back to contactsection.jsx. The snippet gave us a placeholder div. Replace that with a semantic section tag. Now let's style this section using Tailwind classes. We add flex, so the section becomes a flex container. Items-center aligns children vertically, and justify center centers them horizontally. Next, BG Black paints the entire section in solid black. Finally, relative sets a positioning context. We add an inline style overscroll behavior, none. That single rule tells the browser when someone scrolls here, Don't let the page rubber band or momentum scroll past this section. It keeps the contact area feeling locked in place, which is useful when we add interactive elements later. Next, we drop in a new div that will become a simple decorative circle. We attach a ref called circleRef, so GSAP or any other script can grab this exact element for animation. Now the Tailwind classes, W24, SM, W28, W32 sets the width. It's 24 Tailwind units on phones, 28 on small tablets, and 32 on medium screens and up, letting the circle grow with the viewport. H24, SM, H28, H32 does the same for height. Matching width and height ensures it stays perfectly round at every breakpoint. Rounded full pushes the border radius to 50%, turning the square div into a circle. Flex item center justify center converts the circle into a flex box and centers any child like an icon or text both vertically and horizontally. Relative makes this circle a new positioning context. Transition shadow duration 1000 tells Tailwind to animate any shadow changes over 1 full second. Shadow LG Shadow Violet 350 adds a soft violet tinted glow around the circle right away. BG gradient to R from violet 400 to pink 100 lays a diagonal gradient that starts as bright violet on the left and fades to a pale pink on the right, giving the circle depth and a pleasant color blend. Next, we add 3 crucial imports at the very top of the file. First, we bring in useRef and useEffect from React. UseRef lets us create a persistent reference to a DOM element, and useEffect runs side effects, perfect for kicking off an animation after the component mounts. Right after that, we import GSAP, the green sock animation engine that will drive our motion, and then Scroll Trigger, the GSAP plugin that syncs animations with scroll position. Registering Scroll Trigger later will let every animation respond to scrolling without manual math. Inside the component function, just above the return, we declare a constant named circleRef and set it with useRef null. When React renders, it will hand the actual DOM node of our gradient circle to circleRef.current. That handle stays stable through re-renders, so GSAP can target it directly for animations. Here there is a small typo. Add the missing T, and that's sorted. Next, the section itself needs a React ref, so GSAP can anchor scroll-triggered timelines to it. So we attach ref equals section ref on the section tag. Just above the return, declare const section ref equals useRef null. React will drop the live DOM node into section ref.current after the component mounts. Inside the circle div, we place a paragraph that reads, scroll down. This line guides the visitor before any animation starts. Because we'll fade and move this text later, give it its own ref, initial text ref, and wire it with useRef exactly the same way. That handle lets GSAP target only the text without touching the circle behind it. Now for Tailwind styling on the paragraph. Text black gives strong contrast against the light gradient. Font bold adds weight so the prompt is noticeable. The base size is text base, but it bumps up on small and medium breakpoints with sem text LG and MD text XL, keeping the prompt legible on every screen. Absolute inset 0 stretches the paragraph to fill the circle's bounds. Combined with flex item center, it vertically centers the text. Text center aligns the words horizontally, so the phrase sits perfectly in the middle of the round button. Now we add the final text block that will fade in after the circle grows. Inside the circle, create a new div and attach a ref called final text ref. Up in the constants, just beneath the other refs, declare const final text ref equals useRef null, so React can hand us that exact node when the component mounts. Next, style this container with Tailwind. Text center centers every line of text horizontally. Relative gives the div its own positioning context. Flex call turns it into a vertical flex box so multiple lines stack neatly. Item center justify center aligns everything dead center both horizontally and vertically. Opacity 0, add the missing value, starts the block invisible. GSAP will fade it up once the intro prompt disappears. Now drop an H1 inside that container. Feel free to customize the wording. Apply these classes. Text black keeps strong contrast against the pale gradient. W20 rem, LG scale 0.4, SM scale 0.25, scale 0.07. Shrinks the text to fit inside the expanding circle. Tiny on phones, a quarter scale on small tablets, 40% on large desktops. Font bold makes the wording pop on medium screens and larger. Text sem, text base, sets a small base size, nudging up a step on small devices. Leading none removes line height slack so the text block stays compact. MB5 adds a little breathing room below. Right beneath the main heading, we place a short, welcoming paragraph, something that gently invites the user to connect with you. We give this paragraph a set of Tailwind classes. Text black ensures the words remain crisp. LG W40 W20 rem gives it room to breathe. Absolute takes it out of the normal document flow. SMMT3 MT1 adds space beneath the title, subtle on small screens, a bit more room on larger ones. MD scale 0.1, scale 0.068 keeps the copy small enough to fit inside the circle with a slight bump in size for readability on medium screens. Next, we place the call to action button, right beneath the paragraph. PX-10 PY2 gives it a gen horizontal size and a slim, elegant height. Rounded XL smooths the edges. BG black makes it bold by default. Hover BG white, hover text black lets it react flipping colors smoothly to signal interactivity. Transition all duration 500 ensures every shift is fluid and pleasing to the eye. Scale 0.1 keeps it miniature at first to match the compact content inside the circle. SEM MT9 MT7 places it precisely below the paragraph, 7 units down on phones, 9 on larger screens. Text now wrap ensures the button text stays on one line. Clean, unbroken, clear. These three elements, the heading, the inviting line, and the call to action, start off scaled down and invisible, waiting for the perfect moment. With GSAP and scroll trigger, we bring this moment to life. Inside a use effect, we register the scroll trigger and build a timeline. The circle grows from small to screen-filling size. The scroll down prompt gently fades and rises out. Then, your contact message fades in. Now, inside our use effect hook, the first job is to register scroll trigger so GSAP knows those scroll-based features are available. One line, gsap.register plugin scroll trigger, flips that switch and makes every scroll trigger call in the component valid. Next, we think about housekeeping. If the component ever unmounts or hot reloads during development, we don't want old scroll trigger instances clinging to the DOM and throwing errors. So we define a little helper function called cleanup. It asks scroll trigger for its entire registry, loops through each instance, and checks whether that instance is wired to this specific contact section by comparing its trigger to sectionref.current. If it is, we call kill true on that instance. That method not only stops the animation, but also removes internal listeners, freeing memory and preventing duplicate triggers the next time the component mounts. And in the very next line, we call cleanup, that immediately runs the function we just defined. With a clean slate, we set the starting values for our 3 key elements using gsap.set, which changes properties instantly without animation. First, we target circleref.current. By giving it scale 1, we ensure the circle starts at its normal size. We also force the background color to pure white, so the gradient we defined in Tailwind will animate away cleanly when we change colors later. Next, we set initial textref.current to opacity 1. This means the scroll down prompt is fully visible the moment the user arrives at the section. Finally, we set final textref.current to opacity 0, keeping the contact details invisible until the circle expansion animation brings them in. Establishing these baseline states guarantees the animation plays correctly on the first scroll, and anytime the user returns, because GSAP knows exactly where every element should begin before we tell it how to move. Next, we craft a single GSAP timeline that will drive the whole contact circle sequence. We wrap that timeline in a scroll trigger configuration so the motion syncs perfectly with the user's scroll. We tell scroll trigger to watch our contact section, trigger section ref. We want the animation to begin as soon as the top of the section reaches the top of the viewport, so we set start to top top. For end, we add plus 200%. This means the animation lasts for twice the height of the viewport after the start point, giving us plenty of scroll space for the circle to expand and the text to swap. Pin true locks the entire section in place while the timeline plays, making the rest of the page wait until the effect is finished. Scrub 0.5 couples progress to scroll position with a gentle half-second smoothing so the motion feels fluid rather than jumpy. Anticipate pin 1 nudges the pinning start fractionally early, preventing a visible jolt when the section first locks. Fast scroll end true lets the animation catch up instantly if the user flicks the scroll wheel quickly, so it never lags behind. Prevent overlaps true ensures this timeline won't clash with any other scroll triggers that might share the same space on the page. Invalidate on refresh true forces scroll trigger to recalculate every measurement if the browser resizes, keeping the effect rock solid on every screen. Great, now we begin filling the timeline with our first two tweens, one for the circle, one for the scroll down prompt. The very first tween targets the circle. Because we add it at position 0 on the timeline, it starts immediately when the section pins. We tell GSAP to enlarge the circle from its current size up to 5 times larger, scale 5. At the same moment, the circle's background color shifts to a rich violet, 93333EA. The ease set to power1.in-out gives the expansion a gentle acceleration and deceleration, and a duration of half a second keeps it snappy but noticeable. In one motion, the circle blooms outward, setting the stage for the contact reveal. Just after that, slotted at 0.1 seconds on the same timeline, we fade the initial scroll down text. GSAP animates its opacity from fully visible to 0, using power1.out as the easing makes the fade slow slightly at the end for a smooth finish, and a brief duration of 0.2 seconds keeps the fade aligned with the expanding circle. The prompt vanishes before the circle finishes growing, clearing the way for the final contact information that will appear next in the timeline. Next, we add the second half of the circle's journey, moving from its mid-zoom to the full background filling size. Inside the same timeline, we call tl.toe again, still targeting circleref.current. Because we place this tween at the 0.5 second mark of the timeline, that last argument, it starts right after the first scale-up finishes. Scale 17, the circle now balloons far beyond its original size, effectively becoming the entire backdrop for the contact details. Background color E9D5FF shifts the violet to a very light lavender, signaling the transition from prompt to content. Box shadow adds a large, soft glow around the circle. Ease, power2.in-out, duration 0.5. Keeps this second phase as quick as the first, so the total expansion takes a single second. By chaining this tween at 0.5 seconds, the timeline delivers a smooth two-step zoom. Great. And the next step is fading in the final text. We add another tl.toe inside the same timeline, this time targeting final text ref.current. We set its opacity to 1, so the contact copy becomes fully visible. The easing curve power2.in lets the fade accelerate quickly and settle smoothly. A brief duration of 0.2 seconds keeps the reveal sharp and in sync with the end of the circle's expansion. By scheduling this tween at the 0.7 second mark of the timeline, the text starts to appear just as the circle finishes growing and glowing, giving a seamless handoff from motion to message. To keep everything tidy, we finish the use effect with return cleanup. That single line tells React to run our cleanup function whenever the component unmounts or hot reloads, wiping out any scroll trigger instances tied to this section. Now let's check it out. Oh, not again. Looks like another tiny typo slipped through. No worries, debugging is part of the craft, so let's do it together. The first hiccup is inside the main timeline configuration. The option should read prevent overlaps, not prevent overlap. That single letter keeps scroll trigger from allowing multiple timelines to collide, so we update it. Next, the property labeled scroll trigger inside that same block is actually pointing to the wrong key. Rename it simply trigger so GSAP knows which element pins the timeline. While we're at it, wrap the entire timeline definition inside a single scroll trigger object to keep everything neat. All the pinning, the scrub, the snapping, the start and end points, they need to sit under one roof so GSAP reads them in one pass. Once the structure is correct, give the code a quick indentation sweep so it's visually clear and easy to maintain. Save, refresh the browser, and the contact circle now expands flawlessly. The prompt fades, the lavender glow blooms, and the final text glides in exactly on cue. Perfect. Time for the finishing touch, the footer. Hop into the components folder and create a new file for it. Inside, spin up a quick arrow function component with an export, the same rafts trick we've used all project. Jump over to app.jsx, import the new footer at the top, then drop it in at the very end of the JSX tree so it sits beneath the contact section. Back in the footer component, swap the placeholder div for a semantic footer tag. Style it with Tailwind so it blends into the dark theme. Give it a solid black background, white text, a generous top margin so it doesn't crowd the circle above, and comfortable vertical and horizontal padding for breathing room. Inside the footer, we drop a first div. Think of it as the frame that keeps everything neatly centered. By giving it the classes max W6XL and MX Auto, we lock its maximum width to a comfortable 64 rems and force it to sit in the exact middle of the viewport no matter how wide the screen gets. Next, inside that frame, we nest another div. Here we add the layout classes flex, justify, between, items, center. Turning the container into a flex box lets us line its children in a single row. Now we place an H2 heading for your brand or name. To make it pop, we stack several Tailwind utilities. Text 3XL sets a bold, eye-catching size. Font bold adds weight. Then we create a soft gradient text effect. BG gradient to R makes the background flow from left to right. From purple 400 starts it at a vivid mid-purple. To purple 200 fades it to a lighter tint. BG clip text clips that gradient into the shape of the letters. And finally, text transparent hides the normal font color, so only the gradient shows through. Next, we add a little connect block for social links. Just under the brand heading, drop in a new wrapper div. This keeps the icons grouped and easy to flex align. Inside that wrapper, the first child is a small heading that simply says connect. Setting its classes to text XL and font semi-bold bumps it up one size and gives it medium weight so it stands out but doesn't overpower the brand name. MB4 adds a bit of breathing room below. And text purple 200 tints it with the same soft lavender we've used elsewhere, keeping the palette consistent. Below the heading, we create another div that will hold the actual icons. Give this container flex so the icons sit in a row, and space X4 so Tailwind inserts a uniform gap between each one. Now for each social link, we add an anchor tag. Inside that tag, we drop an icon component from React Icons. We imported Figithub, FiLinkedIn, and FitTwitter at the top of the file so they're ready to use. The icon component's own classes, W5H5, lock its width and height to 1.25 rem. Finally, we style the anchor itself. Text Gray 700 provides a neutral base color that blends with the footer's dark theme. Hover Text Violet 400 lets the icon glow with our signature accent when the user hovers, and Transition Colors tells Tailwind to animate that color swap smoothly. Repeat this anchor for each network: GitHub, LinkedIn, Twitter. And it sounds like I have made another typo. Yep, the Twitter icon import was misspelled. Once that's corrected, the icons render perfectly. Now, just below the div that houses our social links, we add one more wrapper to hold the traditional footer details, things like copyright text on the left and a quick nav or credits line on the right. We give this wrapper a series of Tailwind classes, each one with a purpose. Border T adds a thin line across the top, visually separating these details from the section above. Border Gray 700. M12 pushes the block down with plenty of margin, letting the social icons breathe. Flex Cull is the default direction on mobile, stacking items vertically for narrow screens. Flex Row switches to a horizontal layout on medium screens and up. Justify Between pushes the leftmost and rightmost items to the edges. Item Center vertically centers both lines so they sit on the same baseline no matter the font sizes. Inside this wrapper, you drop whatever static details you like. Maybe a copyright notice on the left and a tiny built with React and Tailwind on the right. Thanks to the classes above, they'll stack neatly on a phone, glide into a row on larger screens, and always sit with precise spacing and alignment. Great job. We're almost finished. The last feature is a slim progress bar that hugs the very top of the viewport, grows from left to right as the user scrolls, and shifts color when each major section comes into view. We build it in its own component for clarity. In sarc/components, create a file named progressbar.jsx. Inside, spin up the usual React arrow function export, then delete the auto-imported React line. Replace the placeholder div. Give it these Tailwind classes. Fixed anchors the element to the viewport, so it never scrolls away. Top 0, left 0 pins it to the very top left corner. W full stretches the track across the entire width of the screen. HFP gives it a sleek 5-pixel height, enough to be noticed, never distracting. B grade 100 paints the track a dark charcoal. This is only the background behind the colored progress fill. Z50 pulls the bar above everything else, so it isn't hidden by headers or section pinning. Inside that track, we place a nested div, the fill, that will expand and change hue. Its class list, hfull, makes the fill exactly as tall as the track. W0 starts the fill at 0 width. GSAP will grow this value as the user scrolls. BG sets the initial color to a rich pinkish purple. We'll update this color dynamically at each section. Transition colors duration 300 smooths any hue change over 0.3 of a second, so the bar shifts gracefully rather than snapping. We add an inline style that sets its width to 0%. This guarantees the bar starts empty every time the page loads, waiting for GSAP to expand it as the user scrolls. Next, we give the outer track a React ref called progress bar ref, and we give the colored fill its own ref, progress fill ref. These refs are like direct phone lines to the actual DOM elements. GSAP will use them to read and write properties in real time. To make refs and effects available, we import 3 helpers at the top of the file: useEffect and useRef from React. useRef lets us create the 2 refs. useEffect runs our animation setup right after the component mounts. GSAP for the animation engine. Scroll trigger for scroll-based timing. Beneath the imports, we declare const progress bar ref equals use ref null, const progress fill ref equals use ref null. So React can drop the live DOM nodes into .current the moment the component is rendered. With the groundwork finished, we're ready to drop into a useEffect hook and tell GSAP, as the user scrolls, grow progress fill ref from 0 to 100% and switch its color at each major section. Inside the useEffect hook, we set up everything the progress bar needs as soon as the component mounts. First line, gsap.register plugin, scroll trigger. We tell GSAP scroll-based features are coming, load the scroll trigger plugin so the rest of this file can tie animations to the page's scroll position. Next, we call gsap.toProgressFillRef.current that says animate the colored fill element. By default, the fill's inline style is width 0%. To toTween will drive it to whatever end value we specify, in this case, width 100%. Ease none removes acceleration or deceleration, so the width grows in perfect sync with scroll. Everything else lives inside the scroll trigger object. That's where we wire the tween to scrolling. Trigger document.body, we pin the animation to the whole document. The bar will respond from the first pixel of the page to the last. Start top. The animation starts the moment the top of the page meets the top of the viewport. End bottom. It ends when the very bottom of the page hits the bottom of the viewport, precisely one full scroll length later. Scrub 0.3, and that couples the tween's progress to the scroll position with a gentle 0.3 second lag, giving a silky catch-up effect rather than a direct jump. Responding to progress updates, scroll trigger hands us a live object named self. We read self.progress, a floating value between 0 and 1 that shows how far the page has scrolled, and round it with to fixed 2. Then we run a set of if-else checks. Above 0.75, last quarter of the page, we tween the fill's color to a deep royal violet in Hecker 7E22CE. Between 0.5 and 0.75, we shift to a bright mid-violet A855F7. Instead of writing the code from scratch, let's save time by simply copying the line from above and pasting it here. Now, all we need to do is update the color value to the one we want. Between 0.10 and 0.5, we use a stronger magenta pink B5389. Below 0.1 on top of the page, we keep a soft lavender pink hex C54BBC. Each color change runs its own half-second tween, so the hue fades smoothly rather than snapping. At the very end of useEffect, we return a function. React calls this when the component unmounts or hot reloads in development. We fetch all active scroll triggers with scrollTrigger.getAll. For each one, we check if its vars.trigger matches document body. If so, we call trigger.kill, wiping out that particular instance and its internal listeners. This guarantees no orphan progress bar triggers hang around if the component is removed, keeping memory tidy and preventing duplicate animations on hot reload. All right, now let's finish things up by adding our new progress bar component to the app.jsx file. At the top of the file, right after your other imports, bring in the progress bar with a simple import statement. Then scroll down to the main return block, and just below the footer slash, drop in progress bar slash. Since the bar is fixed to the top of the screen, its position in the JSX doesn't affect layout. But this is the cleanest way to load it with the rest of the page. Now save and check the browser. You'll see the progress bar stretching across the top and smoothly updating as you scroll, with the color shifting based on your scroll depth. And that's it. The portfolio is complete. If you had any issues or need clarification on any step, leave a comment below. I'm happy to help. Thanks for watching, and I'll see you in the next video.